for their support in organizing this program. I also extend my appreciation to the faculty, coordinators, and organizing team for their dedication in bringing together this well-structured learning experience. Lastly, I welcome all the participants to this FDP. As we embark on this enriching journey of knowledge sharing and skill enhancement, I encourage each of you to actively engage, exchange ideas, and take full advantage of the expertise offered in this FDP. Wishing you all a productive and insightful learning experience. Thank you. Bindu ma'am.
Thank you, ma'am. Thank you, ma'am, for the welcome address. The journey of this FDP and its significance will now be presented by Dr. J. R. Lindsley, Associate Professor and Head, Department of Electrical and Electronics Engineering, NISH. I invite Dr. J. R. Lindsley to present the report of the FDP. Now I invite Dr. J. R. Lindsley to present the report.
Respected dignitaries, esteemed guests, faculty members, industry participants, research scholars, and dear participants. It is my privilege to present the report of this prestigious Atal-sponsored online faculty development program on advanced technologies for smart power systems, organized by the Department of Electrical and Electronics Engineering, Noorul Islam Center for Higher Education, Kumarakoil, in association with AICT Training and Learning, Atal Academy, AICT, New Delhi. This 6-day FDP has received an overwhelming response with 290 participants from all over India. The participants include academicians, industry professionals, research scholars, and students, representing various esteemed institutions and organizations across the country. The primary objective of this FDP is to provide in-depth knowledge of emerging technologies in smart power system, focusing on digital transformation, automation, AI-driven solutions, and sustainable energy practices. The program has been carefully structured to cover a wide range of topics, including emerging trends in electrical systems, AI techniques in power generation and distribution, productive maintenance using machine learning, blockchain application in energy trading, IoT-enabled smart metering, automation using PLCs, renewable energy systems, and energy market dynamics. In addition to expect lectures, hands-on training session will be provided to the participant experts in IoT-based smart metering solution and advanced energy management techniques. The inaugural function is graced by the presence of Dr. Thirumal Velavan, Registrar, Noorul Islam Center for Higher Education, who have delivered the inaugural address, and Mr. Beryl Chandra, Software Development Manager, Cineverse Technologies, Bangalore, who will deliver the keynote address. Their valuable insights will set the tone for this knowledge enriching program. We extend our heartfelt gratitude to Atal Academy, AICT, New Delhi, and Dr. Mary Cynthia Rajesh Prabha for organizing this FDP under Electrical and Electronics Engineering Department. We also thank the esteemed speakers, faculty members, and participants for their enthusiastic response and commitment for making this program a grand success. We look forward to an enriching and insightful learning experience in the coming days and hope that this FDP will serve as a platform for knowledge sharing, collaboration, and for in the power system area, technology areas. Thank you.
Thank you, sir, for providing us with a comprehensive overview of the program. Now it is time for the inaugural address. We are honored to have with us Dr. P. Thirumal Velavan, Registrar, Noorul Islam Center for Higher Education, who has graciously accepted our invitation to inaugurate this FDP. I now invite Dr. P. Thirumal Velavan to deliver the inaugural address.
Good afternoon. respected dignitaries, esteemed speakers, faculty members, and dear participants, Mr. Beryl Chandra, Dr. Bindu, it is with great honor and immense pleasure that I stand before you to inaugurate the 6-day AICTE Atal-sponsored online faculty development program on advanced technologies for smart power systems. On behalf of Nurul Islam Center for Higher Education, I extend my warmest greetings to all the distinguished guests, experts, and participants who have gathered here to embark on this journey of knowledge and innovation. AICTE Training and Learning Online Faculty Development Program is a remarkable initiative that aims to equip faculty members with advanced knowledge and skills in emerging areas of technology and research. Through high-quality sessions led by eminent experts, Atal provides a platform for educators to stay updated with the latest industry trends and methodologies. This online format ensures flexibility and accessibility, allowing participants from across the country to engage in meaningful learning experiences that can be seamlessly integrated into their teaching and research endeavors. At a time when the energy sector is undergoing a massive transformation, this FDP aims to provide valuable insights into cutting-edge advancements that define the future of power systems. The integration of artificial intelligence, digital twins, blockchain technology, and IoT-based smart grid solutions is reshaping the way we generate, distribute, and consume energy. As educators and researchers, it is imperative that we equip ourselves with these modern tools to stay ahead in this rapidly evolving domain. The Department of Electrical and Electronics Engineering at Nurul Islam Center for Higher Education has always been at the forefront of fostering research and academic excellence. This program, in association with AICTE Atal Academy, is yet another testament to our commitment to delivering quality education and facilitating industry-oriented skill development. The topics covered in this FDP, including AI-driven fault detection, predictive maintenance, and energy market dynamics, will provide an in-depth understanding of the challenges and opportunities in the smart power sector. I would like to take a moment to acknowledge the dedicated efforts of our esteemed program coordinators, Dr. J. Arun Lindsley, Associate Professor and Head of the Department of Electrical and Electronics Engineering, Dr. D.M. Mary Cynthia Regis Prabha, Associate Professor of EEE Department, and Dr. B. Ben Sujita, Professor, Computer Science Engineering, and also Dr. Bindu for their invaluable contributions to this FDP at NISH. Their unwavering commitment and meticulous planning have played a pivotal role in bringing this FDP to fruition. Their expertise in the field of power systems and their passion for fostering academic excellence have been instrumental in shaping this program to meet the evolving needs of educators and researchers. I would like to express my sincere gratitude to AICTE and the Adult Academy for their continuous support in enhancing faculty capabilities through such insightful programs. To all the participants, I encourage you to make the most of this opportunity by engaging actively, exchanging ideas, and exploring the collaborative research possibilities. The knowledge gained from this FDP will undoubtedly contribute to shaping a more resilient, efficient, and sustainable power infrastructure for the future. With these words, I formally inaugurate the Advanced Technologies for Smart Power Systems Faculty Development Program. May this event be an enlightening and transformative experience for all of us. B.B. King said once that the beautiful thing about learning is that no one can take it away from you. So with these words, I thank you and my best wishes for the successful conduct of this FDP program. Best wishes. Thank you.
Thank you, sir, for your enlightening words and for inaugurating this FDP with your inspiring address. Moving forward, we have a special keynote address by an eminent expert in the field of AI technology and smart systems, Mr. Beryl Chandra, who is a software development manager of Srinivas Technologies, Bengaluru. He has got 15 years of industrial experience in the field of artificial intelligence, IoT, edge computing, and data science. We are delighted to welcome Mr. Beryl Chandra, software development manager, Srinivas Technologies, Bengaluru, who will now deliver the keynote address. I request Mr. Beryl Chandra to take over the section.
Yeah, thank you all. Thank you all for this great opportunity. So I'm very happy to be part of. So I just give a short introduction of me. So I'm a technical and software development manager in Srinivas. Srinivas is one of the giant in the telecommunication giant in the globe. So, and we are spread over 180 countries and more than 80 products we are having. So we are, as a software developer, so we are focusing on the automation right now. So we are having the power of AI and the automations, IoT devices and all. It is helping us a lot for moving towards the automation. So this is how our actual process is going on. Like so as the today world is moving towards the automation, all of our motive is moving towards them. So the data is playing the key role here. So how we can get the data and how we are utilizing all those data. So like that is the main part we are playing. So maybe I can say something about those things. Like so we can say that like we are getting the data from IoT devices usually, right? So I came across a smart device and saw a smart manufacturing unit last couple of years. I am happy to share those things to you. So that is located in Germany, and they are producing some of the manufacturing products. Like we can say any of the products we can say, but I just for the example purpose, I'm saying something like some of the mobile devices or something. They are doing end-to-end automation. So that is really awesome idea, and we came across like whatever the things they are doing without manual interaction they are doing. So whatever the input and raw material they are feeding to the machine. So after a lot of process, it will come as a final end products. So in between we cannot we might see like quality, and we might see some raw material we need to feed to the appropriate product mechanisms. Such kind of the manual interaction might be there. No, not at all. It is not there. So they were did entire thing end to end automated. If you are seeing any automated machine, we can see only we can see all of them in the monitoring screen. So in a single computer, we can manage the entire mission as an automation. So like, for example, I'm saying something about that. They are feeding the they are feeding the raw material in a particular place, and this raw material feed itself will be the automation one. For example, from January to December, we might see like various occasions are coming, various celebrations are coming, like Diwali, Christmas, or something is coming. So based on that, they used to have some kind of how much amount of quantity the consumable by the customer they might see in the based on the statistics. These all the things will be collected by the actual data, and these based on this data, the raw material quantity will be fed to the mechanism, the automated machine. So the inside of the mechanism, we might see so many endpoints will be there. So in between all the endpoints will be needed some services, maintenance, and some of the monthly maintenance or somewhere we can say. So all the equipments having their own IoT devices. These IoT devices will, we cannot say one or two IoT devices because the mechanism have so many endpoints and so many areas to be serviced and so many areas to be keep on having the monitor. So all these info, so we can say, for example, roughly we can say thousands of sensors, thousands of IoT devices will be there in the manufacturing unit. This all the data will be shared with the cloud every 10 millisecond, 20 millisecond kind of. So we can, these all the data will be fed to the cloud, and we can say to the data lakes, and from there it will be managed by the mechanism, whatever we have made, and it will be the needed data will be filtered to the actual relational databases, and from there it will be monitored by the proper applications. So this monitoring won't be stopped up to this point. It will be derived as reports. It will be derived as what are all the needs to be done in the future as well. So such kind of the things will be happen in the monitoring side as well. So these all the things, like for example, so some of the let's assume that some of the pipe or knobs got problems, like repaired. So need to be repaired. So in that case, the sensor will be sent immediately. This particular area is having the problem right now. So we need the service person immediately. Otherwise, we need some of the solution for that. So the automated machine itself have their solution, and it will go directly, and it will do the repair by themselves, and it will, the production won't be stopped in that point. So the complete system would be automated in this way, and end of the time, so we will get the final product in the whenever we decided, and however we managed and however we programmed, and all the statistics and all the mechanics detail will be logged in the statistical reports, and based on that, in future, next year, next to next year, and even now, how we can manage this machines, and how we are processing all these units, and all this information will be handled by the monitoring system itself. And here we can manage all the sensors and IoT devices also from here itself. So all these things all together, we can say the end-to-end automation system along with the IoT and powered by the data science and all these things. And along with that, now they are including artificial intelligence to automate more than this. So this is how they are managing this mission. We can say that automated production mechanism. So that is located in the Germany, and I was part of the team. I was happy about that. So that I would like to share this information with you. So yeah, it would be a little bit beneficial for the team. Might be that's the reason I just shared. So if anyone have any question on that, yeah, you can ask anytime, or you can DM me anytime. Yeah. And moreover that, yeah, this is how my day-to-day life. We used to, I was started my career as a software developer and scale up the skills towards the data science and the AI. And here, this is how I scale up the skills. And actually we were having the big team right now in Bangalore to handle more than 80 products. This is how the things are going on. Yeah, I can say, yeah, this much now. So if anyone need any more information, you can DM me anytime. Yeah, thanks for the opportunity. Yeah.
Thank you, sir, for your valuable insights. Your words have truly set the stage for an engaging and informative FDP event. As we come to the conclusion of this inaugural session, it is time to express our gratitude. To propose the vote of thanks, I now invite Dr. B. Vensukita, Professor, Department of Computer Science and Engineering, NISH.
Good evening to everyone. It is indeed a moment of honor and privilege for me to deliver the vote of thanks on this wonderful occasion of inauguration of our 6 days Atal sponsored online faculty development program on advanced technologies for smart power system in occasion with AICT Training and Learning Academy, New Delhi. We extend our deepest gratitude to our University Chancellor, Pro-Chancellor Academic, then Pro-Vice Chancellor Academic and Pro-Vice Chancellor Administration, our Vice Chancellor, the Registrar Sir, for extending permission to organizing this FDP in a smooth manner. We extend our heartfelt thanks to our Registrar Sir, Dr. P. Thirumal Valavan, gracing this occasion with your presence and for delivering such an insightful and inspiring session. Your expertise, thought-provoking ideas, and in-depth knowledge have truly enlightened us. Always, your words are motivating and extending guidance to all us for our achievements. And also, you are being a role model for us to do our work in the university. We extend our thanks to you, sir. And also, we extend our thanks to our Atal team in charges for providing permission to organize this FDP. Next, a heartfelt appreciation and thanks goes to our esteemed keynote speaker, Mr. Beryl Chandra, Software Development Manager, Cinnabus Technologies, Bangalore, who has shared his valuable insights and experiences on this session. It was a really motivation to us, and also you have given how the industries are achieving their highlights in the field of artificial intelligence, IoT, and big data. Really, it was very useful, and we extend our sincere thanks for providing your valuable time with us. Thank you. A special thanks to our resource person and subject experts who are all going to involve to make the FDP as a useful and successful one. And today's in this inaugural session, we extend our thanks to Dr. J. Arul Rinsley, sir, Associate Professor and Head of the Department, Electrical Engineering, for providing a valuable inaugural address for this session. Next, I extend my sincere thanks to Dr. D.M. Mary Cynthia Regis Prabha, ma'am. Actually, she's the coordinator for this FDP. She has taken a lot of pain to organize this, and today it has come to a successful one. Thank you, ma'am. And next, I extend my thanks to Dr. Bindu, ma'am. She is behind the scene to facilitate smooth coordination and organization of this program. Next, I extend my thanks to all participants for your active involvement and enthusiasm to make this event as a successful one. Your engagements will truly enrich the learning experience for all of us. Once again, thank you for all your contributions to making this FDP a grand success. Wishing everyone continued growth and success in your academic and professional journeys. Thank you once again. Thank you.
Thank you, ma'am. With this, we conclude the inaugural session of our ATAL-sponsored FDP. Thank you all for your presence. We look forward to an enriching and insightful journey ahead. Wishing all participants a great learning experience. As we conclude the inaugural function, we now move forward to the much awaited expert session. It is our privilege to introduce our distinguished speaker, Mr. George Sam Devadhas, who will be delivering an insightful session on emerging trends driving the future of electrical systems. An overview. Ma'am, shall I start the session? Ma'am?
Yes, sir. Madam, sir.
Shall I start, ma'am?
Yes, ma'am. Yes, ma'am.
Okay, ma'am. Thank you. Now it is my pleasure to introduce our esteemed speaker for today, Mr. G. Sam Devadhas, as General Manager, Regulatory, Power Sales and Policy Advisory at JSW Energy Limited. Sri Sam Devadhas is an accomplished power sector professional with over 20 years of experience in thermal power plant operations, technical services, regulatory aspects of the energy industry, power sales and policy advisory. He currently serves as General Manager, Regulatory, Power Sales and Policy Advisory at JSW Energy Limited, where he plays a pivotal role in regulatory compliance, power trading, tariff computation, and policy advisory for the energy sector. Prior to this, he served as Assistant General Manager, Operation Services and Technical Services at JSW Energy Limited, where he has been contributing since 2010, overseeing critical operations at the Toranagulu Ballari power plant. Initially, he worked for STCMS 250 megawatts LFPP for over 7 years and TCP Limited Power Division 63.75 megawatts TPP for more than 4 years, gaining extensive expertise in power plant operation and maintenance. Sri Sam Devadhas holds a master's degree in power systems engineering from Annamalai University and a postgraduate diploma in thermal power plant engineering from the National Power Training Institute, NPTI, Neyveli, where he graduated with first class with distinction. He also completed a specialized program on the regulatory framework and commercial aspects of the power sector at NPTI, Faridabad, deepening his knowledge of Indian electricity laws, power trading, open access, and tariff computation. His academic foundation includes a Bachelor of Engineering in Electrical and Electronics Engineering from Babuji Institute of Engineering and Technology, also earned with first class with distinction. With his extensive experience in regulatory affairs, power market dynamics, and policy advisory, he continues to play a key role in shaping the strategic direction of JSW Energy and the broader Indian power sector. We extend a warm welcome to Mr. Sam Devadhas as he takes us through his insightful talk. Welcome, sir. Now, I hand over the session to Sir Sam Devadhas.
Yeah, thank you, ma'am. Thank you for the nice introduction. Yeah,
Yes, sir.
I hope I am audible for everyone. If any audible or any visual issues are there, then please let me know that. So,
Audible, sir.
yeah, thank you. I hope the time is in the dawn, so hopefully everybody should be shrewd enough so that I think we can able to go ahead with a positive session ahead of. Okay, almost the introduction is much ahead actually whatever they have been told. So I think I can able to meet your expectations. So first of all, thank you for the organizing committee and the electrical and electronics department who is organizing this program. And the professors, as well as the research scholars, as well as the industry experts, and the students, those who are aspiring to become an industry-oriented people, actually just for those actually who are aspiring for. So just before I'm starting a presentation, I want to have a brief thing about be active and alert. Anything is there, actually you can able to interrupt me at any time. while on the process of movement of this slide itself. As you all know, electricity is a commodity now. So you can able to say that. I think it is like a whatever actually what we are going to take in our on a day-to-day basis, like in the market while we are going for buying any groceries or something, it has become a commodity, one of the commodity. I hope everybody will be agreeing with me. So if you are not, what you can say, if you are not competitive enough in the market, so you will be lost. So if you want to become a competitive one, so you should be effective enough in the way of your cost as well as the delivery. So both are very, very important. So with this background, I'm just switching over to, so the things, whatever I am going to cover, I'll just share my screen now. Just the screen is visible, right?
Yes, sir.
Yeah.
The screen is open, sir.
So with the background of our, this is our energy complex in Tornagalu, where I worked with. So just I have put as a background. So which is having a, about 1460 megawatt. It is a thermal plant. The background, whatever we are seeing is our boilers, and the chimneys, whatever we are seeing is majestic about 250 meters of height. So with this, I will go into the presentation now. So this is our tagline of lighting up a billion dreams. So the overview, what I'm going to do is now what is a power scenario in Indian context and how we have come up, and a brief about JSW Group and JSW Energy Limited, and how the grid management is, and how we are evolved from a part-by-part grid system to a one nation, one grid. And I'm coming to the chapter, which is our topic of discussion today. So that is a topic, 3 topics I'm going to plan to finish it up by today's session. One is this optimizing the market link DSM. So this I will explain what exactly is. And the major challenge nowadays, actually, what we are facing is the renewable energy integration. So what it is, I will let you know. And how to optimize this, what all the methodology or new techniques what we are having for optimizing the operation cost. Okay, these are the things I'm just going ahead. And a few of the areas where we can able to focus on the research hunt that I will tell at the way forward. So this is a flow of presentation. Now let's go. So I hope actually you might have been come across this slide in your previous occurrences, where you can able to say India in the generation part, we have come up like in a big way. Since from independence, it's about 1362 megawatt. So we are very meager at that time. The coal is about 756 megawatt is a coal. And the diesel generators and hydro plants. We are these are our initial portfolios. Now you can able to see it's about the coal, the total installed capacity is about 441 gigawatt. This is as of the last financial year, where CES published a report. So if you can able to see the trend, you can able to see there are several spikes in certain years, especially if we can able to see the year 2003 to 2015. So 2003 to 2015, because 2003, the Indian Electricity Act has come into effect. So all the liberalization, your inflow of actually the foreign investments that came to India. So wherever JSW also party to it. If you know that, I think we have started up with a tie-up that I will come to know in the later slides. We have started with a company called Tractable Belgium, which is originated from Belgium. So a lot of inflows of foreign investment was there. Yes, that if the demand is also high, and our growth path also in the very steeper way, and the rules and regulations were very free enough. So generation, there is no need of getting a license to install any thermal plant or any plant. So in that context, I think there were a huge inflow of this one. So that's what I think you can able to see at the initial stages. Since 2018, there is a huge jump of the installed capacity into the sector. And afterwards, actually, you can able to say there is a slow phase. The phase growth is very slow. So this I will say, actually, the inflow of renewable energy capacity and the stagnation of coal-fired plants. So that we will see in the breakup of subsequent slides. So it's just a description of whatever I mentioned there. Actually, in the it is a just depiction of the pie chart only. It is actually you can able to compare the between this what you can able to see this saffron one, not saffron one. This red one is of a coal, and the green one, sorry, the green one is of renewable energies. So renewable energy in the sense, don't think that it is only for solar and wind. It is a renewable energy in India. We can able to say that it is a combination of small hydro. Small hydro means any hydro plants which is having a capacity of 25 megawatt and less. Those are called small hydro plants. And wind and biomass and what you can say waste to energy type. There are difference between biomass and waste to energy. Okay, so and again as you were solar, and again actually solar also will play it. So all these things are combined. Actually, you can able to say it's a RE. The rest of the things are actually the thermal. So if you see this gradually, this renewable energy is capturing means a equal share of your thermal or actually your what you can say the thermal's percentage of installed capacity. You can able to see the subsequent slides. Here you can able to see the 31st March. It is about 1,43,645 megawatt is installed capacity. By see, if you see the data of December, if you can able to see, it's 1,58,000. I am just finding out this green one, 1,58,550. So this you can see this RE inflow on a year-on-year basis. It is about 12 to 13% of RE inflow is there on a year-on-year basis. So why is it so? Actually, why this RE inflow is there, and how we are managing this RE inflow to a base load. Because if we can able to see all this RE renewable energies are in a hydro plants, these are called actually you can able to say it's a peak load plants. Because there is no need of any separate any startup procedures, or actually there is no need of a big procedure which is involved in bringing up the energy. So say for an example, in a thermal plant, for startup actually it requires nearly about 6 hours minimum. So I'll tell in the later stage of this one while we are describing about the thermal plant in its activities. So, but anyway, the thermal plant is called a base load plant. So this, if you know about this evening peaks and morning peaks. So this morning peaks and evening peaks are measured by this hydro as well as this RE part. So and at the same time, the cost of the thermal plant installed capacity as well as the fuel, the cost on the fuel. These are the add-up points, which is as well as your pollution. So recently, this COP26, if you can able to see, all these emission norms are very stringent. So the thing is that actually we should come away from the thermal or the emission, whatever actually the emission making this one too, you should come to this green power. So that is a present trend. So that's what actually you can able to see the part of this RE is more. So this is the same. Actually, it's earlier the slide is having a total capacity. This is the part of coal or lignite based plants. Coal or lignite based plants also, it is following almost the same trend from 2003 to 2018. You can able to say the early stage of 2018. The inflow of coal, or actually the coal based thermal plant or the lignite based thermal plants, which are very high. And this I just shown as a picturesque this one for NLC, the Naval Lignite Corporation. This where we have undergone all our training. This one, and when we studied in NPTA, just as this one I just put a depiction only. There is nothing more. But one point I want to stress in is actually there were in India, while thermal plants were being what you can say incorporated by BHEL. Earlier, there are only two designs. Okay, one is the Russian design, that is called this LMW design, and the other one is called the KW design. So this LMW designs are what you can say very sturdy. Here you can able to see the first 3 units of NLC. Those are called belongs to this LMW, and the rest this 4 units all are 210 megawatt. They will call it stage 1 and stage 2. So this stage 2, this 4 chimneys you can able to see. So these 4 are KW machines. So KW means Kraftwerk Union, and LMW means Leningrad. It's simply you can able to say in the English terms Leningrad Machine Works. So it is based on Russia. So the machines are manufactured from Russia. So this is a nuclear-based plants. Nuclear-based plants, as you know that, I think it is almost all. This is also in the stagnant way. As of now, the installed capacity is 8180. The latest one is the Kudankulam of 2 into 1000 megawatt capacity. And government is having an ambitious target of construction of 21 new reactors and bringing upscaling the capacity to 1500 and 300. So which is a very ambitious target by 2047. So gas-based plant. So gas-based plant, those are not very economical, because most of the gas-based plant in India were run through naphtha or LNG. So these plants are not viable now, because as this cost of this or the landed cost of this plants will not be viable. So because if you can able to see earlier, actually this one plant called this GVK Jagrupadu. So those plants are actually really run with gas based. So in the year of almost in 1998, so they were very flourishing, because that time the availability of gas was there. Nowadays, actually, you can able to see the 1 kg of LNG, it is costing about 80 rupees, 80.75. This is the latest data. So it is not very cost effective. So this is just for information I have put. India's largest one, which is located at, which is a Pragati gas-based plant located in Delhi. So 1500 megawatt capacity. And diesel-based. So diesel-based, you might have been aware. I think there are 2 types. One is the injection type diesel. So there actually the fuel is only LDO, and the other one, the fired, where the fuel is being fired inside the boiler. So there we are using 2 types of fuels. One is HFO and another one is called LSHS. So HFO in the sense heavy fuel oil, and LSHS is nothing but low sulfur heavy stock. LSHS, low sulfur heavy stock. So which is nothing but the advanced version of HFO, because HFO is even banned in few of the areas. So there actually they are using the LSHS, but this is also not very economical. If we can able to see in this basin bridge, where actually it is the biggest capacity, it was working since, and it has been, I hope it has been decommissioned in the year 2018. So hydro plants, actually these are the big assets. If you can able to see all the in Karnataka, if you can able to see in Sharavati, these are peak load plants, because there is no need of waiting for peaking the power in the evening to meet the evening peak loads. You can able to just admit the water into the turbine, and immediately the power will be generated. Whereas the case actually it will not happen in a thermal plant or so. So that's what these are very valuable assets. But the only thing is that due to the getting of several clearances, especially this forest clearances and all, whereas we are also incurring actually that I will let you know. So getting a forest clearance in a particular area will be very a tougher task, especially the eco-sensitive zones are actually very restrictive areas. The clearance part will be very tougher task, where actually it will be going for years together to get into a clearance. So people will not be very much, unless otherwise they are very ambitious as well as getting the land at the right time. So they will not go for this large capacity hydro plants. So the core of the discussion now is the renewable energies. So the renewable energy, as I told you, it's a combination. Whatever I am showing this graph, actually, it is a combination of solar, wind, small hydro, and biomass and waste to energy. So especially this trend has started from 2009-10. It was started in a very pilot way, and actually now it is only, you can say, without renewable there is nothing is there. You can able to the thing has gone to that extent. So why the thing? If you can able to see the installed the project cost, the O&M cost for any, actually you can able to say a solar or any wind, actually it will be very negligible. Whereas if you compare for a thermal plant, it will be very much, you can able to see, say for a thermal plant, it will be around 24 paisa to 26 paisa per kilowatt hour. For a thermal plant, actually for running the O&M business. Whereas actually it is because a thermal plant, it is having a lot of ancillaries. Ancillaries are more. So if you can able to say it's a boiler or turbine or generator, it's a subsequent auxiliaries, it will be very tougher task to maintain. And it's a very complicated system. So whereas in a renewable case, only your installed or actually your project cost will be the bigger one. Once you install, actually, then the running cost will be very meager. So typically you can able to say it's about installing a wind turbine. We are taking about a project cost of about 7.2 crore per megawatt. You can able to say, including the everything, your land, procurement and everything. So now government also easing out several policies to bring back the renewable energy into the upscale one in the form of what you can say they are actually repowering the machines. In fact, actually in Tamil Nadu, especially in the area, in the Kayathar area, so the government is now planning for repowering the machines. So repowering the machines in the sense, actually they are now the wind and all, actually it will run, or the effective the wind speed you will attain whenever actually the wind velocity is more than 7 meters per second. As well as actually you should not have any wake loss. Wake loss in the sense, actually there should not be any turbine which is standing in front of you, or you should not have any, because once the work done in a wind blade, so whatever the swirling effect is there from that blade, it should not it should not be captured. The wind, whatever actually it has been passing by the first turbine, if it passes to the next turbine immediately, so then again it will not do any work done properly. So this is generally called as wake loss. So that's what the MNRE also giving some guidelines, that I think you should install the wind turbine in a way that it should have a distance of 5D70. 5D70 in the sense, I hope, I think you are all are together with me. If there is anything if I'm going away, then please let me know. So 5D70 in the sense, actually it is nothing but 5 times your diameter. So any wind turbine, it will have a height of about 132 meters, as well as having a hub dia, and that hub dia, in that I think 5 times of that fan hub dia, it should be kept as 5D, 7D diameter, 5 times the diameter of that hub dia should be kept as a clearance for one turbine or the spacing between one turbine to another turbine. So there are several land issues which we are facing while taking a wind turbine into consideration. So that is only the constraint actually we are facing. So that also government has given a norms now. So government has fixed some norms that I think in Karnataka, they have framed a very good policy called Karnataka Renewable Energy Policy 22-27. You can also go through that. So there actually you can able to say any wind turbine, for installation of one wind turbine, the land allocation for a wind turbine will be 4 acres. So that I think you cannot capture a big area and you can able to say that this is mine or something like that. So government has given a clear-cut norm is that I think you can able to install a wind turbine within that 4 acres itself. So why I am saying all these things means government is also taking a lot of steps on bringing the renewable energy into a bigger way. You can able to say now government is also having an ambitious target. Now by you can able to say by 2030 we should achieve about 200 gigawatt. That is our target, national target. So that has been decided in 2019. So we are marching towards it. Already we are almost closer to that. So so anyway, that the project is coming. The plan is coming up very well. So in RE sector, actually, you can able to say the states actually which are having a higher stakes are actually I given just only the 4 states: Rajasthan, Gujarat, Tamil Nadu, Karnataka. So you can able to say that Rajasthan is leading in a solar, so which is a very high scale. They are having in a one place called Badla, which is having a solar capacity of about 2,245 megawatt it seems. And other than this, Karnataka also we are having in Pavagada. So Pavagada we are having a one. It is near Tumkur district in Bangalore. So about 2,050 megawatt actually. It's a one single place actually where the solar park is installed. And subsequently, we are proud enough that JSW also got a share of about 300 megawatt of installing a annexure to that to 2050. So we are now on the job of it. So coming up, so these are simply the photos just I kept for insight over it. And this is a typical ground mounted solar because there are 2 types of solar panels are available: the ground mounted solar and rooftop solar. So this is a ground mounted solar one. And just for information, given that footnote, it's about 81,814 megawatt is the installed capacity of solar as of 31st March 2024. And just a brief run through, I'll just go through what is what JSW is and what is the journey through excellence. And the background, what you are seeing is the coils which has been produced from our own plant itself, which is located in Vijayanagar. And this is our vision, bringing a positive transformation to every life we touch, and with a hashtag of better every day. And you can able to see that I think JSW Steel actually, which is our main business, actually we are having, which is the having a capacity of manufacturing of crude steel of 26 million ton per annum, and which is we are targeting of 36 million ton per annum. And in Vijayanagar itself, Vijayanagar means what I'm saying in Bellary, we are having about closer to 18 million ton per annum. That's single largest steel manufacturing unit in India. So we are marching towards to 24 means 24 million ton per annum by the end of 2025. So subsequently, we are a big power producer too, and we are having a target of about 10 gigawatt by 2025 and 20 gigawatt target by 2030 with a 85% stakehold of renewable. So, and we are by 2050, we want to make the carbon footprint zero in the JSW portfolio. So that's our target of, and we are having other verticals also by the form of cement, JSW Cement. You might have been seen the advertisements, and JSW Paints and Infra and JSW Ventures and JSW Sports, which is promoting a lot of Olympians into Indian sport ecosystem, as well as you might have been seen this Bangalore FC. That is one of our face of the football clubs in India. So, and we are doing our all the CSR activities through this JSW Foundation, where actually we are the one of the major successful. This one is Janam Se Janani Tak. Janam Se Janani Tak, in the sense actually we are helping the maternity maternity mortality rate. Our management is very much particular about it, and a village called Vadu in Bellary, I think we have adopted, and in that I think the mortality rate during the pregnancy, it has been 0 now. Right now, again, actually, this is same thing what I have told earlier. So the background is our Baspa hydro plant. JSW is having a hydro portfolio also, about 1300 megawatt. And this is our growth portfolio in the financial year 2021. I think we are having a 4.6 gigawatt, and now we are closer to 10 gigawatt, and we are marching towards 20 by the end of FY30. And this is our share of green energy as well as the conventional energy sources. So these are our pan-India proliferation, and our mother plant is in Vijayanagar, which is of 260 megawatt, where it is of 130 megawatt into 2, which I told you already. The year of 1998 to 2000, we have commissioned those plants, which is a mother plant for JSW Energy, which we have started from 260 megawatt, which now it has been grown up to 10 gigawatt. 10 gigawatt means 10,000 megawatt. So such a whooping figure actually we have moved to. So our portfolio, it has been diversified from 260 to another 2 more units. So that's what this Vijayanagar 860 megawatt, and Ratnagiri, you can able to see Ratnagiri is in the state of Maharashtra, where actually we are having 1200 megawatt, 4 units of 300, and Barmer 1080. It is of it is located in the Jalipa mines. It is 135 megawatt into 8 units. And we are having a hydro units which is producing 1391 megawatt. If you can able to see this 1091 and 300, so which is a acquisition from JP Power. And other than this, JSW has entered into RE business in the year of 2020-2021, and we have been successfully commissioned 225 megawatt solar project in Sandur, which is a small village in Bellary district, and another 733 megawatt, that is closer to 800 megawatt. Actually, we are doing in the adjacent district. And in Tamil Nadu also, our portfolio has been extended in the Tuticorin and Dharapuram. So there actually we are selling the power to the other stakeholders in Rajasthan through the SECI. SECI means Solar Energy Corporation of India Limited. And one of our other project which is coming up is 240 megawatt. So all put together, actually we are about 10 gigawatt by this year end. So this is nothing but whatever I explained it. So that I'm moving ahead. So fine. So here actually in the Vijayanagar area, it is of that, as I told you, this is a 2 into 130 megawatt plant, which has been commissioned in the year of 2000, which is of, and it is a challenging plant. I think how it is a challenging plant in the sense, earlier actually we had a tie-up with the tractable, as I told you. So why we have gone into thermal business in the sense, actually we earlier we are having our prime business is steel. So while preparing steel, I think there is one gas we have been it has been it is a byproduct gas which is called a Corex gas. So all of a sudden, actually, we checked the calorifically of the gas that seems to be around 1830 kilocalories per nm cube. We were surprised to see that, why can't we use this gas into our boiler? So then the process thought, that's our management vision. Then again, actually, we gone to the thermal business of installing 2 into 130 megawatt. So you might have been seen that I think a Corex gas is nothing but the major composition is of carbon monoxide. The carbon monoxide actually, which is a very poisonous gas. So as well as it is an odorless gas. So such a gas, I think, then again people were told that I think Tractable has told that no, it is a very safety hazard. We cannot go with you. So we are going to break your this one. So you do your business as you want. So then we took as a challenge, and again we commissioned this to 130 megawatt, and we made this through that I think by firing that into that boiler to it can able to take up both coal as well as gas. So now that is a mother plant that is having a that got very several accolades from all over India. So when we commissioned that plant, I think we just got this Ministry of Powers this gold award for the best performance as well as for the best PLF plant load factors. So there are several achievements actually we have made through that. So on seeing this such a story, we have entered into buying of another 300 megawatt plants from China that is made from Shanghai Electric. So Shanghai Electric Company, there we have commissioned another 4 more units. So whereas actually 2 into 3 into 5 I mentioned is that belongs to JSW Energy, and the 2 belongs to a captive plant that is belongs to JSW Steel. So that JSW Steel is having 830 megawatt captive business. Captive means in the sense captive means it's for their own production. So that is called a captive plant. So the other plant actually where we are producing the power and selling to grid, that is called a IPP. It is an independent power producer. So this is our journey through. So where we are from Jindal Tractable and actually where we are standing now. So from 260 megawatt to 6090 megawatt. Right now again actually we have ventured into 225 megawatt solar in 2022. That also now came into our portfolio. So this is just a depiction just to show that I think what exactly we are feeding in and what is the output. And again, actually we are firing a coal which has been imported from South Africa and Indonesia. And you can able to say the outcome is power and ash, and whatever actually the ash which has been produced, actually we have been using it 100%. And whatever we are seeing in the slide, actually it is of the bricks, whatever we are manufacturing, and again actually it has been sold, and it has been used for our own internal use also, and a part of it is being used for cement manufacturing. So where actually the part of cement manufacturing, all the cement plants actually they are using this ash. So and one of the best initiative whatever we are doing is the effluent treatment. Effluent treatment is not some actually wastewater we are using that. It is the hardened water. Hardened water means actually whatever if you might have been heard that the condenser is nothing but actually where because in a thermal plant it is a closed cycle. Closed cycle in the sense the water cycle is a closed cycle. Once you feed the water in, it will be circulated within the cycle itself. So the thing is that it will be produced as steam. Then again, once the steam actually it has been done, the work done in the turbine. So then again, once the turbine, the work is done, then again it will be recondensed back into water, and then again it will be used back. So that's what I am using. We are reusing. So for condensation of this water, actually we are using this water, raw water. So the raw water actually which will be used in it will be flow through one equipment called condenser. So once actually the raw water is flowing to the condenser, and once the steam is falling over the condenser bundles, tube bundles, it will be condensed into condensate, and the condensate will be collected, and again it will be used into the boiler again as a cycle will continue. So I am saying this hardened water, which is having a calcium hardness more, generally the water will be called as a blow down. The blow down water, they will throw it outside. So, but what we are doing, we are installed a RO into that for using that water back for our gardening as well as for our other utilization. We are using that water. So that's what just as a one of this best this one. So that's what I just shown that slide. Right now, coming to the point. So now anything actually, if you want to ask in this, you can able to ask me with this what we can able to come across. So it's just a overview. So now I am going to the point, whatever actually we are going to discuss, the emerging trends. Fine. Be brisk and interactive. Because thing is that the time is like that. Okay, so yes, it is off of your college or actually whatever the working hours, even for me. So please be active. And any question is there, if you are unable to catch up or if you are unable to, because most of the slides, whatever I have shown till now, so those are very common slides which you might have been come across through several presentations, right? Hello? You are there?
Yes, sir. Yes, sir. We are here.
Yeah, fine. Okay,
Okay.
just for confirmation. Right, so some of the emerging trends actually which I want to put off, so that's a point of discussion today. So one is this flexible operation of thermal power plants. Actually, what is this flexible operation? I'll explain. And the rest, the biggest thing is the renewable energy integration. So renewable energy integration means what? What is renewable energy integration? That we will discuss in the subsequent slides. And DSM. DSM means deviation settlement mechanism, that optimization of DSM. So optimizing the power sales. And a little bit of condition monitoring I am touching. Condition monitoring this in the sense it is nothing but a predictive maintenance. Predictive maintenance in the sense before anything going, before a breakdown. Okay, a stitch in time saves 9 like that, no? So it is the same thing. Actually, you are just assessing the equipment before actually it is going for a breakdown. That's what I just meant for a condition monitoring. And it is whatever I mentioned, the startup time reduction, it is pertaining to the thermal plants, actually, which is a very vital one. So the analytical tools in the sense, actually, it is mainly for to identify the deviation of any process parameters and to identify the drain points in the sense, actually, there are some of the KPIs which will be stuck to any power plant, right? So, so those KPIs, especially a few of the things I'll spell now itself. I think one important KPI is called heat rate. So hope you might have been heard this term heat rate. So heat rate, what it impacts means I'll tell you. Heat rate is nothing but in a thermal context, how much is the heat energy it is required to produce 1 kilowatt hour. This is called a heat rate. In a simple term, how much is the heat energy you are admitting into the boiler to produce 1 unit of power, that is called a heat rate, which is a very vital parameter. You will be surprised. I will show some figures because people will be very much particular about them whenever they are pricking into their pocket, isn't it? So actually, that's what at the beginning itself, I told you electricity is a commodity. Okay, so I worked in OSTS, so which is almost, you can able to say it's a techno-commercial department of a thermal plant. So, so every day my duty is that to go through all the KPIs. So in a thermal plant, generally you'll have several KPIs like plant load factor, availability factor, specific oil consumption, specific coal consumption, heat rate, auxiliary power consumption. Okay, so there are several factors are there. Hope I think most probably by some of my peers or some who may be attending this this one who has worked in this thermal industry may appreciate this, or maybe come across this such parameters. So those are the things which are very vital. Yes, those are the drain points. Yes, if you want to be cost effective, you should plug off all the drain points. Now, why I put this OSFI in the sense that that's one of the best monitoring tool nowadays. Actually, the each and every equipment sensor is been captured in the form of a tags, and those are brought in the form of a monitoring. Say one simple example, I'll say if you can able to see a boiler inside, actually thermal, I am just telling about more on thermal only. Now in a boiler, generally a coal fired boiler, it is prone to have a lot of slags, or actually you can able to clinkers, what you can say, call it is a clinker or slag. Both are different. Not clinkers and slag are not same. Soot, clinker, slags. So these are prone to stick to the walls, because actually, if you see the boiler, it is like a room. It's like a room, like a 4-walled room. So inside the room, actually, you are firing in the four corners. Actually, you are having the burners located where actually your firing of fuel will take place. And once the coal has been fired, a part of this will be captured in the form of soot, in the form of ash, and it will deposit in the what you can say, the pressure parts. Pressure parts we will generally call as I told you, the boiler has been constructed in the form of walls. Walls in the sense, actually, it will be called water walls. Water walls in the sense, boiler, don't think that I think it will be look like a drum. Drum is not a boiler. So water wall in the sense, each and every the walls of boiler will be constructed in the form of a wall tube. A tube, actually, it has been put and it is welded together, and it will be it is made a form of a wall-like structure. So inside that wall, the firing will happen, and again the water which is inside the tubes will be getting heated up, and again it will be converted into steam, and the separation will be taken in the drum. So it is a regular process. Just on the process, why I am saying this, analytical tools importance. So the soot formation inside the boiler cannot be read from outside or from a naked eye. So there will be certain sensors are placed inside. So generally there will be some soot blowing. I told soot. Soot means it is nothing but it is form of a ash. So for blowing the soot, there will be some soot blowers will be there. Like that, nothing but actually to dislodge the clingers or whatever the ash it has been captured in the walls. So that I think whenever actually the slag or clingers it has fallen down, the heat flux or the real heat will be go and hit on the wall, so that again the heat capturing will be more. So for that, what we'll have generally, we are having the soot blowers. Generally, what we will do in this, we'll have a time-based soot blowing. Time-based soot blowing in the sense, one shift we are having in thermal plants, we'll have generally 3 shifts: morning shift, afternoon shift, and night shift. So people, what they will do, morning actually, okay. One time actually you will do the soot blowing totally actually okay. And night shift fellow will come and again, okay, we will do the soot blowing again. So there is no condition based or the local condition of the boiler. It is to be sensed, and again the soot blowing to be done. Yeah, soot blowing doing actually giving a bath to the boiler will reduce your efficiency. So now there are actually intelligent soot blowing systems are coming to effect. Those will understand what exactly the heat flux which is there in the boiler, whether actually the heat flux is transferred in the boiler tubes or not. So the sensors are made like that, and again accordingly the soot blowing will take place. So those I mentioned some of few of the analytical tools that I just given here. That is also a part of it. Just I given a brief now itself, right? So before I'm going to discuss about this RE integration and DSM optimization, I want to just give a brief about the grid management in India and what is one nation and one grid principle. So in Indian power sector, if you see, so there are several authorities which has been there in Indian power sector, which has been controlling, the topmost notch is the Ministry of Power. So which will make all the framing the policies, framing the policy, like any policy if you take. So the policy will be framed by, say for an example, the target of the RE means wind target or solar target, everything. So now actually the Prime Minister will go to COP26, and again actually if he is attending and if he is committing something there, then some policy to be framed to meet out that. So the policy framing will be lying with Ministry of Power and CEA. CEA is a statutory wing of MOP, which will the main focus is drafting of policies. Mainly all the Electricity Act and the policies will be done by the CEA. And the regulatory, CERC is the Central Electricity Regulatory Commission, which is the authority for framing the regulations. All your regulatory aspects will be done by your DSM also, your deviation settlement mechanism, or any, say for an example, one tariff order. Tariff order is coming. Tariff order in the sense what? Say for an example, now for any thermal plant, it cannot fix the tariff on its own. So based on its coal linkage and based on its heat rate and based on its plant performance, the past history, CERC will fix certain tariff for that the power which has been procured from all the central generating stations, CGS. So the CERC also having a framework of framing the regulations on time-to-time basis. And APTEL, Appellate Tribunal for Electricity. So it is having a role of, what you can say, some cases are there. It is like a Supreme Court. APTEL is nothing but almost like it is like a court only. So if there is a dispute is there, then again people will generally, it will go to the State Regulatory Commission. All the states are having their own regulatory commissions, which will be controlled by totally, it will be centralized by CERC. So then again, if it has not been resolved, then again actually it will go to CERC for getting some clarity over that dispute, actually whatever it has been done. Mainly it will come on the tariff or some unsettlement, whichever it has been there. If it has been not been sorted out there, then they will approach the APTEL. So the APTEL will give it is like a setup of like a Supreme Court, whatever actually the judge and everything, the hearing will happen, and again actually the ruling will be there. So that will happen in APTEL. So you have seen that one policy maker, one regulator, one court actually, or whatever actually to resolve the disputes, as well as the next one is the what you can say, the grid operator. Grid operator is nothing but in India it is called POSOCO. It was called POSOCO, and recently they changed the name to Grid India Limited. POSOCO means Power System Operation Corporation Limited. Now it is renamed as Grid India. So mainly it manages the NLDC, and along with this 5 regional low dispatch centers in India, which has been there. So this is the setup now, and again I will come back to how Indian grid is working. So prior to 1991, so the grid was distributed individually. There were some 5 grids: northern grid, eastern grid, northeastern grid, western grid, southern grid. So all the grids were separate. So each one is having its own frequency separately. Okay, so there is no, if there is one localized blackout happen, there will not be any support from other region to the concerned region. So now in the year of 1991, the east and northern grid were synchronized. And in March 2003, the western grid is the largest grid among all the 5 grids. The western grid has been synchronized with this eastern and northeastern grid. So, and it has in August 2006, actually the one totally the new grid, northern, eastern, western, northeastern grid, all are mixed together, and it has formed a single grid called a new grid. And only the south grid was not been connected. And hope you might have been aware who are watching this presentation. So this 2012 June and July, July 30th and 31, actually there was a big blackout that India has faced. So blackout in the sense, hope you might have been aware. What is blackout? Blackout is nothing but actually the total power supply failure. There are 2 things, one blackout and brownout. So brownout is nothing but the partial blackout, or the half of the things were still live and half this one. But blackout is a total supply failure, including everything total. So it was about nearly 18 hours, okay, to restore the supply back, other than the vital systems like defense and railways. So 18 hours, the total country was almost in a very this one, except the southern states. So there, then actually it is a big eye opener. Then only each and every state has to make their own startup procedures. Actually, where the startup power to be getting, from where to bring the startup power, and what all the things readiness to be kept there, what all the communications to be kept ready during this exigencies. All the things were thought of, and again actually the final resort actually they have made is they connected this. This is a typical actually that frequency drop actually during that disturbance, great disturbance. So just it's a typical representation. I just made this slide. So okay, this is a brief. This one of that blackout or whatever actually it has been happened on the 30th and 31st July. So then again, the southern grid has been tied up with the northern grid, and after that, in 2013 December, after that there will be one nation, one grid, and one frequency. So we are now actually anywhere in India, wherever actually you are seeing installed a frequency meter, and if you see the frequency, it is there from Kanyakumari to Kashmir, it is the same frequency. So right now we will come to this how we are going to optimize that. This is one of the emerging trends. Because DSM means what? Deviation settlement mechanism. So what is deviation? First of all, deviation from what? So some question arises, isn't it? So what is the deviation? First, before that, I think we will understand what is the tariff. Tariff means what? Then again, actually, it is just a prelude. Just actually, I'll patch up this with the main this one. So tariff in the sense, I think you will have capacity charges. So the capacity charges components are actually, you will see that actually it is interest on loan, depreciation, R&M allowances, and O&M. R&M means renovation and modernization, return on equity and maintenance spares, and the secondary oil costs. So all these are coming under capacity charges. And the other one is the energy charges. Energy charges is nothing but it's a variable one. So variable one is nothing but it is the fuel cost. So always actually whatever you are spending for the fuel, these are called energy charges. All the other things which are having the left one, those are called as capacity charges. The tariff has a breakup of only these two. So it is almost a two-part tariff, which is built for the capacity and energy. So one is the fixed. So there is a capacity charges is a fixed one. Why I am saying it is a fixed means this will not change. Once the project cost is fixed, almost all the things which is in the left-hand side, which are fixed. So the variable charge, which is the energy charge, which is a dynamic one, which is in your hand to control. That is a challenging job of anyone actually who will work in a plant, power plant, especially who are working as a O&M heads or operation and maintenance heads, actually whose main challenge will be how to control this variable charges. Along with that, there is one more component it has been added is the unscheduled interchange or the deviation settlement. The deviation settlement, it has the name was earlier called as UI. You might have been, most of the people might have been heard this term UI. What is UI? UI is nothing but unscheduled interchange. Unscheduled. Because I am not scheduled, it's an unscheduled one. Okay, so because of that unscheduled one, the interchange is happening. Which interchange is happening? I'll explain in the subsequent slides. So availability based tariff. So what is this availability based tariff in the sense? So tariff, you might have been seen that what is in our households actually, how much is the energy we are spending. So that will be billed at the end of the month. So that is a tariff actually we know that, isn't it? But whenever actually we are as a say for an example, I am from JSW. So I am having in my kitty about 300 megawatt today to sell outside. So this 300 megawatt, how I will get the paisa in my hand? The paisa will be for the 300 megawatt which has been metered. Metered in the sense, whatever it has been read by the meter, whether I am going to get billed for that or am I going to build on the other way? It is on the other way. That is what called availability based tariff. Availability based. So any power plant or anyone who is going to wheel or sell their power, so they should declare their capacity or declare their availability. Say for an example, I should declare today, tomorrow, how much I am going to sell into the power market, into the market. That's what I told you. Electricity is a commodity. So how much I am going to sell into the market tomorrow, I need to decide by today itself. So then I need to declare the availability. Say for an example, I am assuming that today, I am planning that tomorrow I am going to sell 300 megawatt into grid. So this 300 megawatt I am going to sell into the grid. How the state load dispatch center will know, or the nodal agency will know that whether JSW is going to sell. So what you need to do, you need to give your availability or declare capacity 1 day ahead. So I am going to generate 300 megawatt tomorrow. So whom you need to give? I need to give to state load dispatch center. So state load dispatch center, what they will do, like this, several generators will be there. Nearby us, actually, we are having Udupi, we are having Bellary thermal power station, like this. Actually, I am just telling about Karnataka because as I am working here, so I know about the nearby plants. So like that, the several plants will declare its availability 1 day ahead to the southern load dispatch center. In Karnataka means actually it is a southern load dispatch center. What the southern load dispatch center will do? They will send this detail to SRLDC. Southern Regional Load Dispatch Center. Actually, here we are located here. Actually, we are having in Bangalore. So what they will do? They will do a forecast that is called LGBR, Load Generation Balance Report. Load Generation Balance Report in the sense how much actually like this all the plants actually it has been giving their power or actually they're declaring their availability, that they're assuming that tomorrow this plant will give this much of power to my kitty or to the state, right? So based on that, they will make their corridors available. Corridor means actually once JSW is giving 300 megawatt, UPSCL is giving 300 megawatt, like XRY or other plants is giving this much, there should be some evacuation. So some power actually, whatever I am being generated, it should be evacuated into the transmission lines. So for that, what it is required? The corridor availability is required. The corridor availability should be decided by the LGBR only. So how they will decide? They will think that I think there are actually several this is there. Now southern grid, northern grid, eastern grid, western grid. So they will see the corridor from one state to other state, whether the transmission line availability is there or not, whether actually this much, say for an example, total Karnataka, now about 12,000 megawatt power is there. This 12,000 megawatt power, if it is to be pumped outside, whether the corridor availability is there or not, that they will come to know by this LGBR. So the LGBR study will be done 1 day ahead. Then actually they will see mark for any contingency. Say for an example, one line is not there. So Talcher Kolar, one line is not there tomorrow. So how much the line carrying capacity, that much actually they will cut in. And they will intimate back to me. Say for an example, JSW, I am giving the availability for tomorrow, some 300 megawatt. So this 300 megawatt I am submitting to SLDC. So SLDC will do this, SRLDC. So Southern Region Load Dispatch Center, what they will do, they will make this LGBR. Based on that, they will see whether corridor is available or not. Then based on this corridor availability, they will give back the power back to the generator. They will give, or you give, whether sometimes actually what this 300 megawatt, whatever you have been given, it will be totally, it will be cleared, or a part will be cleared. On what basis? On the basis of this LGBR as well as this your availability of your corridor. So the name of whatever actually you have been declared, it is called a declared capacity. Once the LDC has reverted back, that is called schedules. That is called scheduled capacity. So one is a declared capacity, other one is a scheduled capacity. Now the deviation will come into picture. Okay, so this is a little bit I explained about the power market because I told you. Okay, this will come little later. So this is the process of what I explained a little back. So once declaring the capacity and again actually the computation of LGBR and converting the available capacity to the scheduled capacity. So any congestion or actually any line breakdown. Congestion means what? If there are so much crowd, say for an example, southern side one line is down, but we are having excess of generation. If the generation is unable to pump through a normal road, then again I need to transfer that to western region. So western region, if I need to transfer that, which has been unexpected, there will be a congestion will take place in that particular nodal point. So then again, based on that this congestion, they will curtail some power in order to flow through that congested zone. So that will be done by the grid operator or the RLDCs of that particular zone. So then once actually the schedule has been done, the schedule will be placed in the market. So in India, we are having two power markets. One is called Indian Energy Exchange. Another one is the Power Exchange of India. Like how we are having this money exchanges, we are having power exchanges, two energy exchanges we are having. One is Indian Energy Exchange, and one is Power Exchange of India Limited. They will have certain commission over it. Like we are any power actually whatever you have been bidding through these exchanges, they will get some certain commission on the part of it. So that is the way it will run. So once actually the schedule has been placed into the market, how the schedule will be cleared, it will be just go through this. This is a good graph that you can able to understand. I think hope all are with me. If there is anything, I think if you are please, I'm going little deviating means actually come back to me please, so that I will explain you then and there itself. So in India, I told you there are three markets are there. What is the day ahead market? Day ahead market only just I explained you. That is declaring the capacity one day before. And again, actually, what you are doing, actually, your availability will be converted into the form of a schedules. And once it is converted into schedules, the price will be decided. What you will do? You will book the schedules into where? The power market. In the power market means the exchanges. Where I told you this Indian Energy Exchange or the PXIL, Power Exchange of India Limited. So how the price will be decided? Both the buyer and the seller will bid the power. Now you see here the sell bid will be marked in the form of red. Okay. So the seller will bid from, say for an example, now 2 rupees per kilowatt hour, like that. I think he will gradually rise. And the purchaser, what he will do, he will go on actually reducing his price gradually. And on one particular point, it will intersect. So this point is called market clearing price or market clearing price. In a particular day, the exchange price or the market clearing price will be done like this only. The power will be sold from a generator to the exchange by this process only. So this is called day ahead market. So day ahead market next will be term ahead market and real time market. This term ahead market and real time market, before I am explaining, I'll just give a brief about it. Because we started with the DSM, deviation settlement mechanism. So deviation settlement mechanism is nothing but it is the mechanism which has been designed to maintain the grid discipline. Because I'm giving the availability, you are getting money for that whatever the capacity you are being declared, or whatever the schedules it has been converted, you are getting the money for it. You are not getting money for the whatever it has been metered. So you should be genuine enough. So if you are committing 300 megawatt and the 300 megawatt, it has been converted into schedules. And once it has been converted into schedules, it is your commitment to give the 300 megawatt into the grid. So any deviation from this scheduled quantum, that is called a deviation. But the deviation will not be kept as it is, because government has given very, very stringent norms. So they given it is a frequency linked. So earlier actually it was frequency linked. Frequency linked in the sense whenever, now also it is frequency linked, but the penalty is based on the frequency slabs. Say frequency slabs in the sense the frequency is having a band of 49.85 hertz to 50.05 hertz. If you are operating within this band, 49.85 to 50.05 hertz, if the grid is within that band, at that time, if you are doing some under injection means whatever the committed schedule, than the committed schedule, if you are generating less, that is called under injection. whatever the committed schedule, if you are injecting more, that is called over injection. So the under injection and over injection, both will be, the charges for deviation will be given on the basis of frequency. So the frequency, if it is low, so that means the grid is demanding. At that time, actually, whenever you are under-generating, it is nothing but some penalty should be enforced on you, because the market is giving a good amount of opportunity to earn in the form of schedules, even though they are not metering your energy, whatever it has been generated. And a trust, actually, they are giving you to maintain the grid discipline. It is your responsibility to maintain the grid discipline. Even though grid frequency is going down and you are actually not maintaining that, then again, you will be penalized on the grid frequency. There is a chart. But nowadays, for monitoring that, whatever it has been done, there in a day, which is having a 24 hours, which has been split into every 15-minute block. Every 15-minute block, the power, whatever actually you have been generated, will be monitored against the schedules. Every 15 minutes block. So 24 hours, if you're splitting into every 15-minute block, it will be totally 96 blocks will come in a day. So all the 96 blocks, it will be monitored against the frequency. What is, how much is your injection based on the schedule? Typically, what you need to maintain, you have to maintain the schedule equal to the actual generation. But if you are deviating between these two, then again, actually the penalty will be very huge. That's what I think it is called a deviation settlement mechanism. So, so this is nothing to go with that. 1 minute. I will just explain about this deviation settlement mechanism. So difference between the actual power generation and the injection with respect to the schedules. The purpose is to maintain the grid security. So this is nothing but I have explained to you the over injection and under injection against the schedule. If you are giving more, that is called over injection, and if you are generating less, it is called under injection. So now, so how it will be linked to the market? So in 2014, CRC has framed a regulation called UI. So that is unscheduled interchange. And later on, actually, the name has been changed as the deviation settlement mechanism, DSM. So this is, as I explained earlier, the grid frequency band between 49.85 and 50.1. Now, how the price of the DSM will be captured? That's what I just explained about the market. There is a called market clearing price or area clearing price that I told about 3 types of market. One is the day-ahead market, one is the real-time market, one is the ancillary service market. So day-ahead market, in the sense I already explained you, whatever we are scheduling the power 1 day ahead. So in that, I think there is no need all your 96 blocks, because your power has been booked in a block wise. 96 blocks, each and every block, the power will be go on bidding, all the 96 blocks. Provided that your price should match with the seller's price, buyer's price. Then only the power will clear. If your power is not getting cleared, then those blocks will be empty only. Okay. So those blocks, you can able to give sell the power. Say for an example, morning, I am bidding at the rate of 5 rupees. Okay. So 5 rupees, I can able to say out of 96 blocks, some 40 blocks are cleared. So rest of this 56 blocks are uncleared. Assume that. So I can able to, I am giving a chance of bidding that power in a real time. That is called RTM, real time market. So the real time I can able to bid the power as a lesser rate. If I place at 5 rupee, I can able to place at little 4 rupee 40 paisa or 4 rupee 30 paisa. Okay. So like that, I think you can able to bid it and you can able to capture the customer or the whoever, which is the bidder or whomever maybe the buyer. So that is called real time market. So, and ancillary services market, in the sense, whenever there is a grid, there is a demand. Either you can able to heard this term called spinning reserve. The generation will be kept as a reserve. So whenever there is a grid demand is there, you are supporting the grid through that reserve. That is called ancillary services. So either ancillary services may be in the form of a real power or a imaginary power. Actually, you can able to give in the form of a war compensation also. Now there are more reactive power compensators. I think people are supporting in the form of ancillary services. So that also be getting paid off now. So now actually the penalty or the normal rate of charge. Normal rate of charge is nothing but the penalty charge for your DSM. So this will be calculated based on the weighted average of this area clearing price or a market clearing price and the real time in the day at market as well as the real time market. So all this weighted average in the sense it is nothing but a simple average. It is along with mixed with its quantities. Quantum of power, it has been cleared in the day at market as well as real time market as well as ancillary services. They will take, and the maximum of above 3 will be taken as the normal rate of charge for deviation. So this is the latest this one. Earlier, what I explained you, CRC has given some norms for each and every step of 0.01 hertz variation. What is the rate to be penalized to a particular person who is deviating? Now it is not like that. It is linked to the market. It is linked to the market. So now this is as per 2812 22 regulation. Now actually recently there is a new regulation is come into picture. It is still stringent. It is still stringent in the sense the penalty charges are so hefty that how much actually the power you are selling, say for an example, 5 rupees or 6 rupees, you are selling the power outside. That cost in that, I think if there is some frequency is very low, 49.85 hertz. So at that time, if you are under-injecting, then 2 times of that power, actually whatever it has been sold, that cost will be taken from your pocket. So that is a penalty now government is incorporating now as of now. Yes, to maintain the grid discipline, all it is. Now, how it has come into the talk of this presentation now, you can also think in this way. Now, say for an example, there are a lot of people actually who are coming up in the form of research. You can able to think in one way how to balance, because a customer or a seller cannot be penalized as it is. Because generally now the coal cost, you may have been knowing that. I think all the imported coal, our plant is running with the imported coal. The cost of coal will be around 7,000 to 8,000 rupees per ton. So whenever the frequency is high, there is no need of giving more power into the grid. Okay, so the thing is, the call of the period is now actually the people should think that intelligent systems which can able to think the when to inject, when not to inject, over inject. Whenever the frequency is there, actually automatically the command has to come to the boiler or turbine actually to reduce the fuel or cut off the fuel. And at the same time, actually, whenever the frequency is low, at that time, we need to support to the grid. So that both active power as well as reactive power, the command has to come. So the systems has to be designed in future in such a way. So that is one of the emerging trends. People are working on this field. So this is one of the emerging trends which is coming across, right? So I will not go into this much detail about it. So this is nothing but the how much actually will be penalized for each and every frequency band, nothing more than that. Anyway, I will share this slide also. So this next we will come to RE integration with the base load. So this is one of the important topic actually we are going to discuss this. Why this RE integration is required? So I will give a simple example. Karnataka, the peak load need to be met is about 18,000 megawatt. In the upcoming months, actually, what they are saying that I think this will go up to 21,000 megawatt also. So what is the way of meeting out this? Either actually you should have the installed capacity up to that much extent, or you need to get from some quantum from the central generating stations, which are having some, because each and every state is having their own quota to get or entitlement from the central generating stations like NTPC, especially NTPC stations only. So generally they will get some quota from the central generating stations. So if some central generating stations are breakdown, then we need to end up in a blackout only. Blackout in the sense actually the part of the load should be shut off, or actually something to be, if you are unable to meet the load demand. So the main thing is that you should keep a flat load curve, almost, not on every time. You should meet a flat load curve. If you see the RE generation, which is uncontrolled load, right? Say for an example in a solar. So solar will pick up in the morning 8 o'clock. And again, it will die down by around evening 4 or 4:30 or something. After that, the intensity will go down, right? So, but what is your peak hour time? So in Karnataka, if you see the morning peak will be morning about 7:30 to morning about 10:30. And the night, I think the peak will be, evening peak will be by evening about from 5:30 to 6, the evening peak will pick up. The evening peak will pick up, and again, it will go up to night 9 o'clock, 8:30 to 9 o'clock. So what about the rest of the times? You can see that most of our solar plants are working in the majorly the sunny day, means about 11, 10, 11, 12. So I'll show one typical load graph of Karnataka. This, if you see, this you can also access this from the load curve from the SLDC, State Load Dispatch Center, Karnataka. So if you see this graph, this red line and green line, those are the generation of solar. So it started from the, if you see the time span, it started from 7 o'clock, and again it is gradually rising, right? So it is going to the peak in the 12 hours, 13 hours, 14 hours, 15 hours, right? So, and it is going up to 17 hours, it is dying down within this period. So what this is happening in this period, your load is actually, it is evening, morning peak is there, but it is there up to certain extent, and again it is started dropping. So your precious load, whatever it has been generated, it has been wasted off, right? Am I true? So the precious load, whatever you have been generated by the God's grace, so that has been wasted off. So at the same time, where your evening peak is there, here actually your evening peak to be met off, but your solar is not there at this time. So what we will do? Anyone is having answer? So here, the integration part will come into picture. So RE need to be integrated with the base load. But are we prepared for it? That we need to think of. So how RE to be integrated, that I will explain. RE integration can be done only in the two possible ways. How? Any answer? Right. Okay, I'll come back. No problem. Because wind is very much volatile. Wind is very much volatile in the sense wind you cannot predict. It can able to go up to a maximum peak at the any time whenever based on the wind flow. It can die down also at any time. So whereas the solar is almost consistent. But the problem here is, I think it will have capture from morning 7 or morning 8 to till evening, actually about 5 o'clock or 6 o'clock. After that, it will die down, right? So what we need to do now, the savior here is either actually you should have a pump storage plant or a battery energy storage system. A pump storage plant or a battery energy storage system. So pump storage plant, if you see, even JSW also, we are also venturing into several pump storage plant. It is like almost like it is like a hydro, right? So your landscape should be good enough to have a upper reservoir and a lower reservoir, and you should not like a runoff river concept. Actually, whatever it has been stored in the upper reservoir, once you are utilizing, you cannot throw away the water back. What do you need to do? You need to reuse back. Right, so that's what the pump storage plant will work. So again, the water will be reused back. So that's what it is called closed loop pump storage system. So don't you think that, I think, will it be economical? Pump storage plant will it be economical? Because you should have the pump, you should have the capacity to pump back that water back from your lower reservoir back to the upper reservoir, isn't it? For that, you require the pumping cost. So will your cost will it work out? No, no, because whatever actually you are generating, okay, for a hydro plant, the power generation will be nil almost. That means generation cost will be nil. But whatever the pumping cost you are making, if you are drawing the power from the grid and you are pumping that water back, what is the use? We are spending nearly about 5 rupees, 6 rupees. And again, actually, we are sending back that water back to the top and again, actually reusing. So it's a waste of this one and waste of thought. So what people now actually they were working on that whenever actually the solar is abundant or this RE is abundant, so that time they will use this water. The pump storage plant will take this RE power, which is of having a cost of about 2 rupee 30 paisa to almost nearly about 3 rupee, nearly about 3 rupee. Okay, so that actually the water will be pumped back to the top reservoir during this peak period of RE. And whenever actually the solar dies down, the power will be used as a hydro plant. Okay, so through this graph only I will explain. If you want any slide explanation, I will move actually that I have prepared, that I will explain you. So during this evening period, so from, say for an example, 6 o'clock, any pump storage plant generally in India, what we are constructing, which can able to withstand up to 4 to 5 hours continuous operating cycle. So means once you fill the top reservoir, it can able to capture the power for about 4 to 5 hours. So your evening peak can be met off. How? By generating the excess power, whatever it has been generated or it has been produced by the solar or wind. And actually you are using the same power for pumping the water back to your top reservoir. So your pumping cost will be around 2 to 3 rupees only. So same power actually you are using as a hydro. Now, again, the evening peak actually will it be say for example 6 o'clock to 4 around again what you can say 4 hours. So night 10 o'clock. Night 10 o'clock afterwards, actually what you need to do? You have to shut down the PSP and you have to start your thermal. Okay. So, but will it be feasible actually for starting a thermal and stopping a thermal? Huh? I told you at the beginning of this one session itself, thermal plant for starting itself, actually it will be, there are 3 startups are there: cold startup, warm startup, and hot startup. Cold startup, it will take 6 to 8 hours. That's a typicality of a thermal plant, because your turbine is a very vital thing in a thermal plant, where you cannot rush and again actually immediately produce the steam and admit into the turbine. No, the turbine is a very delicate one, and you should have a very narrow clearances. The clearances will be very narrow between the rotating part and the stationary part. So it should be evenly, what you can say, the stress to be relieved, and it should be evenly expanded. For that, I think the time should be given. So for that only the time is required. So how we can able to manage this again rest of the period once the pump storage plant is died down? So either one way you can able to keep the I can able to say that I think you can keep the turbine under warm. Turbine under warm in the sense actually you can able to keep the we are having a system called a bypass system. Bypass system means that, because I didn't bring you the thermal plant slide. Otherwise, I think I should have explained you properly. There will be once the steam has been generated from the boiler, so it will be admitted into the turbine. So instead of admitting into the turbine, we will bypass back and it will be dumped into the condenser. That is called bypass. So there are 2 types of turbines are there: one high pressure turbine and low pressure turbine in a thermal plant. So high pressure turbine, once you bypass, that is called HV bypass, and low pressure turbine, once you bypass, that is called LP bypass. So this high pressure turbine and low pressure turbine, you should bypass the steam and keep the boiler warm, because boiler should be kept ready. Once actually the PSP is died down, this steam to be admitted into the or within this 4 hours period, you should warm the turbine properly. And once the PSP is died down, you should start the thermal plant and running till the morning, the solar will pick up. So this is called integration, right? So RE integration will happen in this form only. So to keep a flat load curve or a load demand, to meet the load demand throughout the day, your three things should be go in a hand to hand. But at the present condition, this is one of the riskiest situation while comparing to the thermal plant alone. Because why it is coming to a risky situation on the thermal plant alone? Our metallurgies are not enough, quite enough to withstand this stress and strain. Because you see, again, evening you need to admit the steam into this steam turbine, and morning you have to stop. Again, you have to start. Again, you have to stop. So the start and stop process will yield a good amount of stress in your turbine as well as your boiler pressure parts. So now this is one of the evolving field, or the this one, how to minimize this stress and strain into the boiler in the form of metallurgy. Because turbine, I think if you might have been knowing, the metallurgy of a turbine comprising of nickel, chromium, molybdenum, vanadium. So it's a major components of a turbine shaft. Okay. So otherwise, what will happen? It will lead to pitting. It will lose your turbine blades strength. It will lose away. Okay. So all these things will happen. So now the research has to happen on the metallurgical part as well as for the automation part too. Why the automation part I am saying? The thermal plant, there is having one thing called minimum load. Minimum load in the sense where we can able to bring down the load without oil support to a minimum possible. CRC has given a guideline. Every power plant can able to run a technical minimum. That is called technical minimum. The technical minimum load of 55%. Say if I am having a 300 megawatt power plant, I can run up to 150 megawatt. Right? Now, actually, the recent guidelines, they are telling to go up to 40% of the load. So even 40% of the load also we can able to go down, right? So that's a demanding situation it is coming. Why we need to go up to 40% or 50% of the load? The purpose is that we should accommodate the RE. So renewable energy to accommodate the renewable energy. Please, if you don't mind, can you mute it that? Yeah, thank you. So, sorry. So this technical minimum load is very, very important in a thermal plant, right? So the technical minimum load, why I brought in is, I think there is a 55% guideline was there. Now actually they have brought down to 40% of that, this one. So now actually the demand is to bring down the load to the maximum possible down without any, because generally all the coal-fired plants will run without any oil support, because oil is a costlier one. Okay, so oil actually, if you are firing, it is a very costliest this one, because 1 kiloliter of or 1,000 liters of your LDO, light diesel oil, will be costing about nearly 75,000 to 78,000 rupees. And your heavy fuel oil, HFO, what we are firing in boiler, that is costing about nearly 55 to 60,000 rupees. So people will not, if you want to produce a cost-effective power, then again actually bringing down to a technical minimum with the oil support will be, which is a useless one. So you should bring, the technology should be broad enough to bring the load gradually to up to 40% or 30%, so that whenever actually the solar or wind power is maximum, at that time you can bring down the load to a minimum and you can keep the thermal plant live. Don't shut down the plant, because if you shut down the plant, then again restarting will be taking you more time. So that is one of the emerging trend, or whatever the emerging technology we should capture in the form of metallurgy, or in the form of how to bring back the load to minimum and again actually ramping up to the maximum. So these are the things actually we should think of. So this is one duck curve. Why I put it here? This is the impact of your solar, and again actually it is called, actually typically called a duck curve. Actually in a typical daytime, the load, if you see, it will be dropping down. And again, actually here the evening period, 6 p.m. actually again it will be peaking up. In this period, wherever actually it is dropping down, your solar generation will be more. Here actually you can able to say around 8 o'clock to this period. Here your solar generation is more. So the duck curve shows that I think how much is the solar been unutilized because of your drop in load. This is a typical PSP. So I hope I think I explained so that I think I explained verbally. So we are having two reservoirs, an upper reservoir and lower reservoir. And during pumping period, it will be going like this. And again, actually, it will be collected in the lower basin. And again, actually, while it will be running in the motoring mode, again, actually, it will be run back and it will be fill the upper basin. So the filling of upper basin only it will happen during this this period, wherever actually your peaking period of solar. In this period, wherever your peaking period is there, this load, this area, you can able to pump back the power. Right. So it is only information only. Where and all actually we are having pump storage plants in India. So in JSW also we are having a pump storage plant actually which has been proposed in Vijayanagar, where in Bellary district of 130 megawatt, we are planning of 130 megawatt. This I told this cost effectiveness. Okay, right. So even though your pumping cost is nil, that this will be 4 rupees 67 paise. So even your pumping cost, whatever actually if you use your because that means how much actually your solar power or wind power or your RE power cost is less, that much actually your levelized tariff for a pump storage plant will be less. So this is a typical turbine, which I explained you earlier. This is a typical 300 megawatt turbine, actually, which is for Tornagalu plant. So the left part of one, sorry, I think I'm just crossing the time. Just I will finish it up fast. So this part is a HP turbine. This is a intermediate pressure turbine. So generally, this turbine will face a problem actually due to this load rising and dropping. This is called the root of the turbine blades. The root of the turbine blades will face a crack. You can able to say wherever I circled, this area is having a crack. And this cracks actually you cannot say that I think it is so minor and you can able to leave because it is running with the RPM of around 3000 megawatt, 3000 RPM. Even a small crack actually it is enough for dismantling of that blade, right? So this I have told you because of this load ramp up and ramp down. Because of that you are stressing the boiler tubes. You can able to see the tube cracks. Because this types of cracks, with my experience, I can able to say that it is because of the high heat flux which has been dumped into the boiler. Dumped into the boiler in the sense, because while rising the load, we need to rise it very fast. So for rising the load, what people will do, they will admit more coal into the furnace. So they will put it more coal into the furnace. Because of this high heat load, it will have some spontaneous erosion as well as it will have this metal peeling in that particular area. So those places actually you will have that brittle cracks. This bottom one actually it is called the fish mouth opening. So fish mouth opening in the sense wherever actually your heat flux is more high. So those places this boiler tube will burst like a it is called fish mouth opening. So these are few of the damages that I have shown for your reference because of this ramping and frequent ramping and ramping out. So the other part I think I am saying is the predictive side. We have to focus it. That is one thing I told you is the intelligent soot blowing system and the location of this furnace fireball. Furnace fireball in the sense I think you should know about where the fireball inside the boiler is. It should be at the center position. So it should not be hit in the either and any one of the corner of the wall. So that actually it will hit your boiler tubes and again actually it will damage the tubes. So for that, I think the recent developments are there because we are having the furnace high temperature withstanding cameras. So where actually it will locate the fireball and it will give back the operator a feedback that the fireball is shifted. So you bring back the fireball to the center like that it is there. And the turbine side, you can able to see there is one new invention called ATRS. This is not a new invention. This is earlier it is there, but actually now it is little bit. The manual intervention part is very less. Automatic turbine run-up system. So automatic turbine run-up system is in the sense, human nature is what? If your boss will pressurize, bring back the load very fast. Yes, sir. Yes, sir. Yes, sir. Yes, sir. I will do it. So that is another concept, I think, because system driven is different. Once you are buckling and doing, that is different. On the orders, that is different. Once you're buckling and doing the order, you will start bypassing all the things, and again, actually, you will do all the mistakes, which will be harmful to the person as well as for the equipment. So now that's what this automatic turbine run-off systems and all, it will have a thing called, it will monitor your stress. It will not allow you to load the turbine unless the stress of the turbine shaft is relieved. So those are the new developments. So I'll close it as early as possible. Please bear for 5 more minutes. So there is a turbine supervisory instruments also now it has been there, especially to monitor the axial shift. Axial shift in the sense, whenever I told you some high pressure turbine. So high pressure turbine, whenever actually you are admitting the steam from one end, and again actually it is, there will be one thrust will be there. The thrust should not make that shaft damage because the clearances are very little. So the turbine supervisory instrument which is mounted inside the casing are actually enough to give the clearances. How much is the clearances are there? That much actually clarity, that much gap. Actually, it will give the clarity that I think how much actually we should maintain the clearances inside the turbine and how much is the steam we should admit into the turbine, and all actually it will be assessed by this TSI. And generator side, one major important thing actually we are facing here. The copper tubes, because generator, it is not like the simple one whatever actually you have been seen in your laboratories or something, because a 300 megawatt generator which will be cooled by water which has been supplied into the stator coils. You might have been heard this, but the thing is that the water quality should be pakka enough. Okay, so in the sense actually it should be neutral. It should be neutral. Neutral should be pH should be 7. So we should test that water very pakka, and again actually that should not be non-conductive enough. And if there is any conducting, or actually if that any foreign body, or if there is any oxidation happen into the coils, then copper deposition will start to take place in the inside the coils. Once the copper deposition takes place inside the coils, actually the slots will be getting blocked. Slots means the stator coil slots will be getting blocked. Again, actually, that will be, then that particular coil will be getting overheated, and again, actually, that will damage. Okay, generally, this is the overhang portion. So, generally, the overhang portion is more prone to such type of damages. Okay, this is a typical one. This is I'd shown two types of alternators. One is the alternator which is of 130 megawatt power plant. This is a 300 megawatt plant which is cooled by water as well as hydrogen, because hydrogen is one of the best cooling media, so which is a more fire hazardous also. So there we are using one system called the seal oil system to avoid the escape of this hydrogen, because hydrogen will be filled inside the generator casing. So between the shaft clearances, there is a possibility of the hydrogen may escape from this one. So further, there is one separate system called seal oil system. So seal oil system will create a thin film over that the clearances, so that it will avoid the escape of the hydrogen. Okay, so generally the generator will be cooled by this hydrogen as well as the stator water. So generally the stator water systems, the thing I told is the condition monitoring of the copper deposition one that we are seeing there. And this rotor, especially this retaining rings are more prone. In my experience, this retaining rings and this fan blades, because rotor is having a blade and they are having its holes, perforated, skewed holes inside this periphery. If you see there, you can able to see these holes. These holes are also we have to monitor properly, because actually that there is a chance of dust deposition inside it. Right, and again, these are the few of these areas which we can, the researchers can able to think of to in the heat rate, auxiliary power consumption, specific oil consumption. These are some KPIs I just given there. So to improve the heat rate, because heat rate improvement in the sense, just I am telling by word, it is not so easy. If you improve one heat rate, 1 kcal heat rate, 1 kilocalorie heat rate, how much is the saving? I'll just show. Please bear with me for 1 minute, right? So this is, I think, hope you may have been, the screen is visible. This is 1 kcal heat rate, if you are saving, then actually your saving will be 1 kilocalories. You are saving about 9,100 rupees. Actually, you are saving 1 kilocalorie. The heat rate loss may be of several types. Maybe I think if you are going through a thermal plant, because thermal plant, I think you cannot say that it is a very sophisticated one, like our lecturer halls. So it is like a plant, I think, where we can able to go and experience once. I think it is having a lot of thermal stress on your body also. So you should keep your eyes and ears open while you are walking through a thermal plant. So you can able to see a lot of leakages here, there actually. First of all, actually, while you are arresting those leakages, half of your all the heat loss will be get rectified. So this is just for a your this one only reference only I'm just giving. And specific oil consumption. Specific oil consumption is nothing but the oil which we are consuming for generation of 1 kilowatt hour. But generally we are not using oil continuously, regularly. Whenever we are starting up, the oil should be minimized at the earliest, at the maximum possible. You see, 0.001 ml per kilowatt hour for a 300 megawatt machine, which is called, if you save, which will be equivalent to about 3.6 lakh rupees, right? Because people will be, it will be eye opener whenever actually you are just seeing that in the form of monetary terms. And outage in the sense actually one plant. Yeah, please. Sorry, somebody has intervened. Please go ahead. Please go ahead. Okay. The outage rate of 1% actually will give a monetary benefit of about 1 crore. Okay, so outage rate means I think if your plant is being stopped, I taken just for 1 day. Sorry, for a month actually, for a 300 megawatt unit, if you stop for a month, so then again actually your outage losses will be about nearly 1 crore rupees. Okay, so auxiliary power consumption. Auxiliary power consumption is nothing but the self consumption, whatever actually you have been doing for your own. So those things actually you can able to work, because now auxiliary power consumption for improvising, there are several things has come up. Because if you can able to see in a thermal plant, actually it is about the major consumer is a boiler feed water pump, which is a 4.5 megawatt capacity for a 300 megawatt. One single pump which can able to consume 4.5 megawatt capacity. So such a big pump actually, if we can able to save, because nowadays we are planning for going for a variable frequency drives, VFDs. So the VFDs are saving a lot, right? So there are several areas actually which has been there for coming up, right? And again, I'm thankful to all of you for hearing me up to patiently this one. So if any questions, please. I think I'm already eaten away about 20 minutes. I thought of finishing my lecture some 15 minutes early. So I took a time more than the committed one. I'm regretting for it. Requesting the form 2. If you are having any questions, please post, please.
Sir, excuse me, sir.
Yeah, please.
Sir, JSW is doing well in thermal power generation. Now
Yes,
we are
yes,
moving
yes.
towards the net zero emission target, right?
Right.
So what
right,
are the
right.
initiatives you are taking? So whether you are having any carbon sequestration units in your thermal power plant, sir?
Yes. Carbon earlier, this carbon sequestration was done by a mechanism called CDP. CDP mechanism actually will give you what we are doing in this case. We are replacing the coal with what you can say the byproduct gas which has been produced from the adjacent steel plant. So because our steel plant which is producing a variety of gases. So one is called blast furnace gas, one is coke oven gas. So one is called your correct gas. So all these gases actually we are introducing one by one. We are doing an in-house modification of all these burners, and again actually those burners are originally designed for burners in the sense which will fire the coal or the whatever the fuel type. So those things actually we are converting back so that they can able to fire this byproduct gases. So those actually activities we are taking up now. So other than this, I think the one which we are going for this RE certificates. RE certificates, or because RE obligations are nowadays coming as a mandate, as a green initiative one, because it is like a person, I think, who was not having any RE, renewable energy, then again, they should buy from the other people. That is called RPO, renewable purchase obligation. So renewable purchase obligation, we were earlier, before 2020, we were purchasing the renewable power obligation certificates from the other stakeholders. Nowadays, actually, we are, after installing our own solar and thermal plants, wind plants, I think we are using our own green energy sources into our kitty. So in that fashion, actually, we are going for this one, zero emission, carbon zero.
Okay, sir. Thank you very much, sir.
Yeah,
So, dear
thanks a lot.
participants, if you are having, dear participants, if you are having any queries, means you can ask to sir.
Thank you for the patience, because anyway, I think it's time is up.
Yes, sir.
This
Thank
is
you
our
very much.
yeah. I think hope everybody is convinced. I think anything is there, just please let me know, or you can able to post me also, or because I think the next speaker also, I think she may be ready, I think.
Yes, sir. Bindu ma'am.
Right.
Okay, ma'am.
So can I log off?
Sir,
One
wait.
second. On behalf of Nurul Islam Center for Higher Education and the Department of Electrical and Electronics Engineering, I extend my sincere gratitude to Mr. G. Sam Devadhas for this insightful section on emerging trends driving the future of electrical systems and overview. His vast experience in power plant operations, regulatory affairs, and energy policy has provided us with a comprehensive understanding of the evolving power sector landscape. The depth of knowledge and real-world perspectives he shared have been truly enlightening for all participants, helping us appreciate the future directions of electrical systems. We deeply appreciate his time, effort, and valuable contributions to this faculty development program. Thank you, sir, for sharing your expertise and enriching our knowledge. Thank you once again, sir.
Thank you. Thanks a lot.
Thank you, sir. Thank you. Thank you, sir.
Ma'am, shall I introduce the
Sheeba
next
Rani
section?
ma'am is also with us, ma'am.
Okay, ma'am. Thank you. So next section 2 starts. It's an absolute honor to introduce our distinguished speaker for today's session, Dr. Sheeba Rani J, a highly accomplished academician and researcher in the field of avionics, signal processing, and VLSI design. She's currently serving as a professor in the Department of Avionics at the Indian Institute of Space Science and Technology, IIST, Trivandrum. With a career spanning over 25 years, she has made significant contributions to the fields of computer vision, pattern recognition, digital VLSI design, and signal and image processing, particularly in designing hardware-efficient solutions for real-time applications. She holds a PhD in electrical engineering from Anna University, Chennai, and ME from Alagappa Chettiar Government College of Engineering and Technology, Karaikudi, and a B from Periyar Maniammai College of Technology for Women, Tanjavur. Since joining IIST in 2007, Dr. Sheeba Rani has held several key academic positions, including reader, assistant professor, associate professor, and now professor. Her extensive teaching experience covers a broad range of undergraduate and postgraduate courses, including digital electronics, VLSI design, digital signal processing, digital image processing, advanced signal analysis, and real-time DSP. She has been instrumental in shaping the academic curriculum at IIST, mentoring students and guiding research scholars in their advanced studies in avionics and digital systems. Dr. Sheeba Rani's research primarily focuses on developing innovative algorithms and hardware implementations for signal and image processing applications. Her work in image analysis, understanding, and performance evaluation of VLSI architectures has led to significant advancements in the field. She has published numerous research papers in reputed peer-reviewed international journals and conferences, contributing to cutting-edge developments in digital VLSI design and hardware acceleration for signal processing. Her research has practical applications in avionics, space technology, and real-time embedded systems, making her contributions highly relevant to both academia and industry. Apart from her academic and research achievements, Dr. Sheeba Rani is actively involved in various professional organizations. She's a senior member of IEEE and an active member of IEEE Women in Engineering, WIE, IEEE Circuits and Systems Society, and IEEE Remote Sensing Society. Her engagement in these professional communities reflects her commitment to advancing knowledge, fostering collaborations, and supporting women in STEM fields. With her vast experience in teaching, research, and professional leadership, Dr. Sheeba Rani continues to make significant contributions to the field of avionics and digital systems. We extend a warm welcome to Dr. Sheeba Rani as she takes us through her insightful session. Welcome, madam. Now I hand over the session
Thank
to
you.
Sheeba Rani, ma'am. Okay, ma'am.
Okay.
Thank you.
Could you hear me?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, shall I share my screen?
Yes,
Okay,
ma'am.
Okay. Hope my screen is visible.
Yes, ma'am.
Yes, ma'am.
Okay, shall I start? Okay, thank you very much for the introduction and for the invitation given to me for the Saddle FDP on advanced technologies for smart power systems. Today's talk of me is on role of ICT in smart systems. So first we can see about smart systems. As we all aware of smart systems, but anyway, once again we can recollect that exactly what smart systems is that. So smart systems enable intelligent real world physical systems. So any physical systems, it will be connected in a smart way by integrating onto communication networks. And also the data from machines, sensors, videos, maps, people, newsfeed, and more to become an integral part of all information systems, integrating, taking it from the physical system and communicating for some actual decision-making process. The decision-making process, because of these steps of connections, we are saying that the decision-making process is that to achieve a efficient and intelligent decision-making process. Or we can say that cost-effective and energy efficient because of this smartness. So what is involved in these smart systems? The main thing is that network of technologies that enable data collection, transmission, analysis, and action within a smart system, which is the backbone for intelligent decision making. So without networks and without data collection and analyzing the data, transmitting the data for taking quick actions or decision. So without network, smart is not possible. There may be a local network, or it may be a wide area networks, or it may be a worldwide network, whatever may be. So a smart system includes networks of technologies. So just I'm showing from this paper, it's not a paper from a commercial vendor. I've taken this from a paper from this website. I've quoted this, right? Now you see the smart systems is classified into, it is given as a 3 types of smart systems. One is a simple applications. All we know in today's world, when we see our home, smart homes. So in the busy world, we are in implementing, people like to have smart homes. It reduce our workloads. So it's a very simple applications that we know, right? Alerts and alarms, right? Alerts and alarms, location services, monitoring, maintenance, like that. So this type of simple applications involve some small sensors with one onboard computers or an embedded system, which collects the information from these small sensors, which is connected, and it will process and will give the respective decision to make action of turning off lights,
or turning off, controlling the speed of fan, washing machines, and all those things we know, if it is a smart home. Now you see, because of the innovation in technologies in the sense that we are saying not only in networks, in all sort of all sort of equipments and roles, the technologies keep on improving. Innovations is keep on coming. The industry and the industries keep on innovating to keep the market in high. So a lot of competitions is also coming. So next comes, we are saying that the compound systems. Many are coming into picture to make things smart. So here, the smart compound systems, we are saying factories, hospitals, and related environmental characteristics. By diverse vendors, users, and stakeholders are using that based on the requirement. This is, we are saying it's a compound system. Then comes that today the need of the hour is complex adaptive systems. Examples you see, smart cities, smart transportations, even the complex adaptive system, smart grids, as in your today's FDP, that smart grids also come into this complex adaptive system. Diverse data fusions. So compound systems are there, complex adaptive systems are there, because when time to time, it can't be static. It has to be adaptive. So the smart system has to be highly intelligent enough to adapt certain environments and circumstances. For adapting these types of circumstances, the network technologies, the sensors or the ICTs should support, right? Now you see, when you're telling about smart systems, nowadays even if it's you're an electrical engineer, you'll be encountering the word smart grids, but not all. But when the common man, when they are seeing, they know the smartness. They have felt, or the day-to-day life, many of the people are feeling the smartness in smart hospitals, you see, smart transportations, smart factories, then supply chain. Nowadays, everything is connected through sensors, the requirement, all those things, right? Supply, whatever we need, right? So we are as an Indian, I'm not talking about the India thing, but it has not evolved that much fast. But when you're just going for the Western countries, when we see that these things are automated, smart transport, smart factories, supply chain, smart hospitals, all those things are coming. So these are all coming in the complex adaptive systems based on the sophistication we require. So now you see an example of a diverse domain. One domain we can take, a smart hospital. What are the other things we are having? You see, the networking topology or networking technologies, which is supporting the smart hospitals. You see, IoTs, advanced control and IoTs. You see that AI/ML, artificial intelligence and machine learning systems. You see the important thing nowadays, augmented reality and virtual reality, right? So we can say that networking managements, hybrid network managements, and we are saying distributed networkings, distributed managers, right? Complex imaging and auto ID. This is also one of the video analytics, image analytics. So when you're going for smart hospitals, this main thing is that sensors plays an important role. For analyzing the data, artificial intelligence, machine learning plays an important role. For making some simulations, real-time simulations, visions, and all those things in smart hospitals, here we are playing an important role. And to connect all those things, complex imaging plays an important role. Then to connect all those things, to make it smart, to take efficient decision, we record all these networks. So one of the examples that we know, this is the thing, right? Smart transportation also nowadays people. You see for smart transportation, what is the difference given for smart hospital and smart transportation? Anyone can say? So you see in smart transportation, networking is very much, but it's crucial because we are taking it smart. Decision making has to be done without any sort of late events, right? Immediately the decision making need to be taken. So for that, we required a very good, strong networking. You see that here, the type of networking which is given is 5G. Vehicle to vehicle communication or machine to machine communication, it is 5G. Okay, 5G plays an very important role because which will be having the latency of communication is less. Within a seconds, we can able to get the data. That's why in smart transport, it is given that. And another one technology you see, GPS. So apart from this smart system varies based on the nature of applications, right? What is required is very much important. Now you see, even though we have talked about different diverse domains of smart systems, all are interdependent. You see this is the smart factories we have seen, supply chains we have seen, smart transport we have seen. See here I have put, this also put as smart agriculture, smart buildings, smart hospitals, smart mining. Now you see the smart grid is coming here. Distributed energy resources, right? How efficiently we can distribute energy. We can maintain energy, we can store energy. That is very important because without that, we can't able to survey. So here see some of the domains which inherently has some smartness. You see that wearables, virtual reality, augmented reality, I've told. Smart glasses coming into picture. You might have seen Google glasses. So it is smart. And we know that Qualcomm has introduced a smart glass, right? So these are the technologies nowadays people are using it for real time. That means they want the things to be done in real like thing using some wearable glasses that we are saying virtual reality, augmented reality, extended reality like that. Next, multimodal sensing, IoTs plays an important role. Batteries with storage devices plays an important role. 3D printing, blockchains, security, digital wallets, digital twins, making using the real information of the physical world and the simulation environment, bringing it together to make things to be done or to be shown, visualizing, right? Digital twins, all are now you see connected. Right? Air and water quality management is a small, simple system. But now for smart mining, it is involved. Smart hospitals, everything is connected. So we are saying that now you see adoption and deployment, interdependency, it is highly interdependent. And another one important thing when you are taking about smart systems, because now this era is smart system era. It is not of the Indian economy, but the general thing says that you see, evolving combinations of technologies will radically transform our lives. Yes, true, it transforms our lives. It makes our lives so sophisticated. And the global economy scaling their equity market capitalizations from 10 trillion today to potentially more than 150. So it is now 10 trillion today. I mean, is that the 2023 article? This is 2023 article. They have given 10 trillion today to potentially more than 150 trillion in 2030. So smart systems is capturing the market and it is scaling the global economy. How it can? Because it requires sensors, it requires network technologies, right? A lot of things, advancements, innovations are required, and many companies or industries are working on that to deliver these types of technologies so that the smart system can be improved. So what are the smart system key components? Now you see, we are having any applications, hospitals, smart grids, power grids. If you are taking, we want to make it smart. What are the important key components which is required for making it smart? Data collection and transmission, which requires sensors. Data analysis and processing, which requires algorithms and softwares. Here comes the AML concepts. Control and automation. Information communication technology enabled automatically control and adjust various processes or devices. Once a decision is taken, it has to adjust. Feedback, all those things. So it has three major components: data collection and transmission, data analysis and processing, and control and automation, right? You see, I've already told smart system innovations impact every industry and market. This is the actual thing. So what are the areas that we are having? So I've told about the three different components, right? Data collection and transmission, data analysis and processing, control and automation. These three you see here, it has captured here. All these things are captured here. You see, multimodal sensing and machine data fusion, networking, computing, software programming, data management, artificial intelligence and machine learning. Then we are saying that AR, VR, content delivery and interaction. These are the 6 different things that is required. It is a verticals, okay? Verticals means each industry is concentrating on this to deliver a good sensing. Good sensing in the sense IoTs. So now you see, manufacturing and industrial, building and facilities, transportation logistics, energy and resources. So yeah, smart grid, energy and resources, also the industries are concentrating, verticals. So as the FDP is concentrating on the smart grid, we can say take this vertical, 6 verticals, and the horizontals we can take. What is the energy and resource? Substation monitoring and machine usage patterns. This is one of the component which is given, multimodal sensing and machine data fusion. So for substation monitoring, what are the sensors required? That is the question that we know, right? Next, high performance networks, computing and digital infrastructure. What type of communication we are going to do, right? The ability to manage grids, because the grid is not a simple grid. It is a large network. We have to communicate between grids. We have to collect information between grids, right? We have to manage demand and provide services. What type of networks we are going to use? Next, software programming developed tools. We know that the second key component is analytics, data analytics. So it is given that analytics on process and equipment to optimize, right? Data management, analytics and information architecture. You see, renewable energy production trends and predictions. You know, predictions. Normally today, the data which is collected from the grids, huge data, we are calling it as big data. How we are analyzing the data? If the companies are very eager to collect these data, because using these data, they'll be having some predictive analysis. Based on the predictive analysis, they've decided on that what innovations need to be done. What could have to be done for making a system to be smart, right? Renewable energy production trends. You know, renewable energies. Nowadays, we are not depending on fossil fuels. You have clearly seen the previous lecture of solar energy and all those things. The expert has clearly explained to you. So today, this trend is normal power grid has to be combined with renewable energy source. So how efficiently we can connect and make it smart, right? Then artificial intelligence and machine learning. In energy and resources, people are concentrating on power distribution, automation and control. Using AI, how we can bring automation. Then you see delivery of peer or local usage statistics and performance. So this is to the fake end of the user, all right? Content delivery and interaction, they are saying how efficiently we can make it. So all are interconnected. It can be put here or there or not. But just we are saying that these are some of the things which is given. Important thing is renewable energy, then substation monitoring, right? Ability to manage grids, manage demand and provide services. So these will be coming in the utility, right? So these are the all these things are important. It should be taken care. Power distribution automation, you see, it should be taken care. Otherwise, energy efficiency won't be there. Cost effective won't be there. So now each industries are capturing their market by putting their aim on this and how efficiently they can bring technologies. That is the important thing. Okay. So now I am using now the word ICT. So information communication technologies. We know are technologies that allow for the collection, storage, processing, transmission, and dissemination of information, decision making. So collection is important, data acquisition. Storage is important. Yes, storage devices are important. Processing, analytics is important. After that, the core information need to be transmitted. Transmission is important. And based on transmission reception, the information need to be meant for that purpose. That's why we are saying dissemination of information. So this ICT technologies in smart systems, what are the different ICT technologies? Okay. So just few only I have mentioned. Internet of Things, all we know, right? Internet of IoTs, we are saying. Internet of Artificial Intelligence is also there, you know, right? All sensors connecting physical devices to the internet for data collection. Then big data analytics, we know already I've told you. Cloud computing. So cloud computing was one of the backbone for these types of smart systems, right? Because we don't want to have a local storage. We are just depending on the cloud. You know about the concept of edge that will come, artificial intelligence and machine learning. That also one ICT, right? So IoT, it's a key sensing device, right? Measurement, control, and actuation related operations in smart grids. Large scale Internet of Things deployments. If it is a large scale IoT, energy efficient IoTs need to be done. Okay. That is an important requirement. Energy efficient form of IoT. One type of energy efficient form of IoT is narrowband IoT. Right? So you see IoT, where the IoTs will be placed mainly deployed at locations where human presence is not possible. Due to the dangers to human lives, it is one of the requirements, but even human presence is possible. Also, nowadays we are keeping intelligent sensors, but in smart grid applications, that is a thing that we can't able to, human intervention can't be made. So there we are keeping these IoTs, right? What are the other different ICTs? 5G networks, we know. 5G networks, what is the advantage? High bandwidth, low latency. And it has the ability to support huge connected devices. That's why when we are having a smart system, the IoTs and the sensors and the sensing device, multimodal sensing devices are huge. A normal network, it's 3G networks, even though it supports 4G, LTE, it supports, but we can't get a very low latency and the bandwidth is also less. So 5G plays an important role. Now in India, we are in the process of getting 5G, right? But in other Western countries, they're enjoying 5G and 6G networks are also in place, right? So many countries, because of the applications of this 5G and 6G, not countries, many industries are working on making efficient 5G networks. If they are making 5G networks, they can capture the market. Then comes the another one, ICT is edge computing. Already you have seen when I'm showing the diagram of this, you see one edge computing is there. You see smart transport, edge AI, workload management, edge. What is edge? Our cell phone is an edge. In the cell phone itself, if it can able to process huge data, and when it is capturing the image, for example, I can tell cell phone is a edge device, right? Mobile phone. Because nowadays mobile phones are used for multi-purposes. It's used for taking image, speaking, image 2D, 3D, then for hearing all the multimedia informations, right? Data, for all purposes we are using. It's not only for communication. These are sensors. It is called camera. Camera is a sensor, right? Apart from that, is having vibration sensors are there, actuators are there, right? That's it capture the vibrations, rotations, positions. Many types of sensors are there in the mobile phone. But if you want to make, suppose if you're capturing some informations and you're processing the information in your edge itself, whether your edge device supports, that is the question. Suppose if your huge data is coming and your edge itself has to process instead of transmitting the data through the net to the networking to the cloud to store the data in the cloud. If your edge can able to support some minimum number of processings and it can take immediately the decisions, that will be of great use, right? So that's why we are saying ICT's edge computing plays an important role because the IoTs are connected to the edge. If the edge is not self-sufficient to process it, it has to transmit the data to the cloud and it has to process it. But if edge is very good, that's fine, right? Okay, next is that software defined networking. So it's a SDN networks, you know, all the communication protocols, communications, everything is now in software. It's having that type of environment. AI and machine learning in networking, not only in networking, in all aspects we are saying, right? Utilizing AI and ML algorithms. So without AI and ML, nothing is there. And it has already been implemented and deployed in networking. Network automation, automating network configuration and management tasks through, again, AI-powered tool. Reduces human intervention. And so just to make use of, to remember that we know Internet of Things, IoT plays an important role. Cloud computing is one type of networking. Just I'm telling 1 or 3, but we have more things, right? Machine learning, each and everything we are just having. Edge computing, software defined networks. These are the different things. But even though we are saying that we are having different technologies, IoTs are there, AML things are there, communication protocols, networkings are there, all those things. What is a major requirement for these ICTs? Different vendors are making different sensors, right? We are having one platform that is okay, software defined radio networking, okay? But when you are just connecting all these sensors and putting it in your particular smart model, smart grid or whatever maybe, whether this ensures seamless communication. The question is whether interoperability is available or not. Many of the networks, it is not available. Okay. So the first major requirement is that if you want to make system to be smart and we are plugging in so many different types of network technologies into the system to make it more smart and efficient from various manufacturers and platforms, but whether it is giving a seamless integration or connectivity. First question. Second question is that data privacy. You know that nowadays data is flooding like anything. The concept now it's big data, it is going big data, big square data. But whether we can have a secure data transmission. So cyber security is very much important for these types of smart systems. for critical application of smart grids, smart hospitals. If some data breach is happening, what is the scenario? What is the condition? You see, not only in hospitals, smart industries, supply chains, in all aspects we require. That is latest research says that still we require a very good amount of research for strengthening the security, cyber security. Okay. So implementing robust security measures to protect smart systems from cyber attacks. Data privacy rules has to be implemented properly. Ethics need to be followed. Otherwise, it's a flop. Right? Same thing, cyber threats, I'm saying. Nowadays, many people, many industries are also increasingly adopting private 5G networks. So they are having their own 5G networks to gain more control over network security. Right? Then we should be in a big giants can only be possible for that. Then Wi-Fi's, all the IoTs are connected and it has to be connected through Wi-Fi. So Wi-Fi is a boon for us, right? So now I'm coming to our thing. I have taken the application as the smart grid, okay? Smart grid. What is smart grid? All of you know. Smart grid is an electricity network that uses digital technologies to monitor and manage the flow of electricity. Right? It uses real-time data, we know. Main aim of the function of the grid is that to balance the supply and demand of electricity, which helps to improve reliability and stability. How efficiently, smartly, we can control and efficiently use or supply the demand of electricity. That is our main aim. So this is a diagram. I have taken it from the same paper. This, I hope so, yes. So the smart grid, right, having so many options, you see, wind power plant, solar power. So these are renewable energy. Earlier power grids are not like that. Earlier it is having the fossil fuel, or we can say that we'll get electricity, right? Normally we are saying that we are generating from the wind, water, thermal, and all those things. It is coming to the power grid and we are supplying, right? Nowadays we want a very smart. So now you see nuclear power plant, thermal power plant, hydraulic power plant, solar power plant, wind tunnel power plant. Then you see that we have to, from this, we are getting the sources, right? We have to supply to all these things, smart houses, cities and office, mainly e-vehicle nowadays. Smart points we have to make, right? So supply and demand of electricity. So sourcing also we have to done it efficiently, generation, right? Generation, then transmission, then consumption. These are the three concepts we are using here. So what is smart? These are the old objectives. More energy efficient. And another one, zero net emission. Direct and indirect carbon emissions from the power generation significantly. We are making smart. Right? Third point is that this is the major thing. To add a large number of renewable energy systems to the main grids. Okay? Then to provide reliable power quality all the day without any interruption. That we require smart grid. And another thing why smart is required, unnecessary wastage can be removed so that excess energy can be stored for future use. Right? Next is that monitoring, the health monitoring of the grids. Each and every health of the grid need to be monitored. Essential parameters of the grids need to be monitored. Voltage levels need to be monitored. Okay. Then to provide complete safety and security of the power generators, and the distributions, not only power generators. Today, the system is distributed. So the smart grid is helping us to satisfy these points. So important thing is that for the sustainability of the environment, indirect carbon emissions, you see zero net, renewable energy is main thing we are saying. Then also safety and security it is ensuring by maintaining the temperature, pressure, and all those things it is maintained. Okay. Not only that, nowadays the smart grid initiatives have also been changed, right? You see, not only energy production is emphasized, but also storage is also emphasized in the new initiative. Right? Emerging power storage networks need smart power management. So we required a very good power storage networks which need smart power management. You see, smart grids will have lot of generation points. This is called distributed generation. It is not that in one end we are just generating. Nowadays it has been changed. Okay, we know large number of renewable energy sources will be added. Not only that, you see, not only that, smart systems, smart grids not only give value added functions. You see, smart grids can support several ICT services, facilitate widespread power line communications. It is supporting power line communications apart from normal storage, generation, transmission. It also provides small office applications, provide infrastructure base for e-vehicles and numerous IoT based services. That means, you see, for example, air quality measurement using sensors, weather parameter measurement, crowd sensing, protection of the services over the grid, safety and surveillance of the STs. So some other value added functions is also done by the smart grids. Okay, apart from its actual requirement, actual functions. So just I'm telling about the smart grid and this thing, then only ICT will come. That's why I have bring this. What is that? This also I have taken it from this paper. Okay, it is 2023 paper. You can see what are all the qualities when we are just defining a power grid. These are the qualities, right? How information is flowing, power generation, grid topology, integration, energy sources, sensors, monitoring, outage recovery, testing, ability to control efficiency. You see from the last efficiency, output by input. Output is the power generated or stored, whatever. Now, as compared to normal traditional grid, efficiency is very high. That is enough for us, right? Ability to control, smart. That's why it's easy to control because all the parameters are in our hand. We can visualize if we have kept the sensor properly. Okay. So now you see this grid topology. It's fully networking. This radial in the sense that we are connecting from the center to all. That is called radial, right? So a center in node is connected to all the grids separately. In networking, it's not necessary to be like that. Power generation is centralized power generations, but it is not distributed power generations. It's a very important point. Information flow is two-way communication. Okay. Next is smart grid domains. Different domains are there. Okay, market is the operation, service provider, transmission, distribution, customer. Customer is an important thing, right? Distribution, generation. Transmission, generation, distribution. This is transmission, customer. Generation. So when we are just saying transmission and customer, when we just see this, you see. Now come to the communication technologies. These are all has to be communicated through communication layers, right? Reliable communication is required for information exchange between different domains to ensure reliable operations. Now you see this wide area network communication layer, not only wide area network, based on the applications we have. So we are just dividing it into, you see this neighborhood area network or field area networks. We'll be having different networks. In this communication layer, not only communication layer, power control layer and power system layer. All these things are coming under the communication layer. Power monitoring, control and management system, power generation and transmission systems. Okay. Right. So the communication layer consists of a wide area networks, neighborhood area network or field networks. Different, depending on the type of networks, different communication protocols are used. Technology means protocol. You know, power control layer, you know, right? Yeah, that means enables management, control and monitoring of the power grid that we know, which is from the switches, sensors and metering devices. Okay, this I am not going too much. So ICT in smart grid, we know smart grids, an enhanced network capable of more precise monitoring of power consumption and facilitating the provision of renewable energy from various sources. These are things we know. Now you see, this is, I'm going to, so advanced information and communication technology tools include, we know, internet connected sensors and switches together with intelligent electronics that are not constrained by limits. So this is a very important thing for our purpose. Okay. So now you see that we'll be having, I'll go into the, okay, internet. It's coming later, so we don't want to now look into this. 1 minute. That anyway, other things are coming into picture. That's why I'm not going to this. Okay. Then I will skip that slides because it is coming again. It's a dry subject, but somewhat you can just take some of the informations. Okay. Okay. Now you see the first and foremost thing, the success of this smart grids. I don't want to say you people are very expert. Advanced metering infrastructure, right? This is the conventional energy meter. This also coming under the ICT because it is also a type of sensor. That's why I'm saying. You see, smart meter system, smart meter connected to a communication interface of protocol gateway, communication interface protocol database. But the manual system is like this. Next, Internet of Things we know, right? IoT. So what are the different things we are having? So different IoTs we are having here. IoT integration is accurate data collection in real time, which help utilities keep track inventory levels or even detect faults, right? Main thing in the smart grid system is this, inventory levels or even detect faults. Another important thing you see, the collected data used by the machine learning algorithms, which is helpful in predicting future patterns based on past trends. So we can decide on the grid or the distributed structure, power, transmissions, right? How it will be. So whether we want to modify certain things so that we can improve the efficiency. Right? Now you see. The energy industry highlighted the need for technological advancements. What are the different communication networks which is used earlier? LTE, okay, long-term evolution, 450. And you see that narrowband IoTs. That's why I've told that for an energy efficient sensors, narrowband IoT is coming into picture. 450 megahertz frequency range, earlier it was used. For critical communication, what is important? Data rate and spectrum access. There comes the concept of 5G. Also, we'll be having GSM or Edge, right? And we'll be having mobile terminal systems, right? And specifications we are using cellular technology. I mean, not only the internets, we are also using the cellular technology for the communications. So these two things are repeating again, right? Next, you see, you might have heard this, or some of them have worked on this. LoRa. It is also a narrowband IoT. It is coming under the low power wide area network. Nowadays, we want the sensors to be of low power, right? Networking, whatever if the networks are used, it has to be of low power, energy efficient. So you see LP WAN technology is LoRa, long range, which utilizes a low power wide area modulation technique to enable long-range communication with low power consumption. Okay, LoRaWAN is the corresponding network protocol that enables secure and efficient communication between LoRa devices and gateways. So these types of devices are in the market for any applications. Hope some of you have used this for your application, for biomedical applications, right? For the smart grid applications. These are embedded system. Along with that, this LoRa kit is coming along with that. So it has so many sensors, pressure sensors, right? Temperature sensors, body sensors, or some of the body sensors is also there. Different, it is connected to different sensors, and we can use it for our application, how it can be made as smart. And it is having an inherent communication protocol, and it will support that. We don't want to do anything with some IEEE standards, right? So you see, this is narrowband IoT. So it is a low power IoT, machine to machine communication, right? So it is an LT device, 180 kilohertz. Earlier we have seen that you see this 7, the frequency is 450, right? Here it is low frequency, 180 kilohertz, but it can be for, that means we are saying that it is a narrowband IoT. It is using the cellular network support. Standalone mode is also there, licensed spectrum in sub 900 megahertz. So the bandwidth is high, then we have to license it. So LP1 already we know. So it is coming under the LP1, low power wide area network, which is an NB-IoT. Okay. So now you see these things, you know, as you are the you are all electrical, right? You know all those things, smart metering, SCADA, right? Then we know that it is a substation. We are saying that we'll be having a substation automations are there, right? And the demand response, right? We know distributed energy responses. Hope you know that. I think so, right? So what is distributed energy resources? So it has the resources have it has the substantial potential at generating electricity at the load end. That's why we are saying distributed energy resources, right? Demand response based on the remote demand response from the consumer side or the utility side, right? We'll be taking some actions. Shift the demand from the peak loads to the some other things like that. And consumers can also see their things and they can shift. They can change their way of style so that the energy efficiency can be improved. Lot of things we are having in the smart grid. So it is not in the normal power grids, right? Only in the smart grid communications. This is so smart grid quality of requirements is. Now you see another one standard, IEC 61850. This is standard which offers interoperability of devices. So you see, I have told that the major requirement of any communication protocols or communication networking devices or IoTs are, it has to support interoperability, right? So IEC 61850, which is a standard which supports this type of interoperability of devices. Now you see, communication network structure. WAN supports 1 Gbps. With small networks, right? Field area network. So it supports 10 MB. So based on the applications, if it is your structure, your smart system is of 100 meter, 10 kilometer, and it is long distance of 100 kilometer, we have to devise our area networks, communication networks, and topologies and protocols to define it. Okay. So already I've told this. I don't want to again repeat. You can see a wide area network, a neighborhood area networks. You see, premise networks. You see WAN and home area network, right? So data rate requirements. This data rate should be like that. What are the technology alternatives? You see this here. For a home networks, because the role of ICT on smart systems, right? ICT plays an important role. That's why I want to stress here. At least we should know these names. Zigbee. Hope you have known this name. Z-Wave, Wi-Fi. Wi-Fi is a boon, right? Wired. If it is wireless, these are the technologies it's people are using nowadays. Or the companies or manufacturers or the industries are providing to support these types of technologies. Wired, Ethernet, home plug, M-bus we are saying. Then we are saying wireless here also the same thing. Okay. Here we are saying that powered line communication that will come later. Then when it is coming to 100 kilometer, you see wired here Ethernet fiber optics is coming. Wireless, WiMAX, 3G, 4G. Nowadays we are talking about 4G, 5G, etc. So these are the technology alternatives based on the data rate we are getting. Okay. So now you see smart grid communication technologies, wired, already I've told Ethernet. At least after this FDP, we should know that Ethernet supports up to how much data rate, okay? You see the fiber optics, it's also 100 Gbps. Ethernet also supports 100 Bs, but what is the difference? Fiber optics covers long distance, 100 kilometer. Ethernet covers 100 meter. So what is the application? In power generation domain, we can use it. Right? In home communications, backbone communications, we can use it. Right? Coverage limitations is there. Network type is this. But when it is 100 kilometer, we should automatically know that wireless. But the installation cost is high for this as compared to this. If it is 100 Gbps, we know it is a high bandwidth. Okay, high data rate. Electromagnetic interference, because we know about the fiber optics, interference is less. But it is wired, okay? Then power line communication, we know the one of the value-added function, value-added service of this smart grid is power line communication. For small data rate communication, less data rate communication, 10 to 500 kilobits per second, up to 3 kilometer, we can use this PLC. Sometimes for the security or the personal, sometimes we are using this for what to say that intra communication between a small network or like that also we are using. Okay. But disadvantage is noisy channel environment. Broadband PLC also 300 Mbps. It is 500 KB. It covers 1.5 kilometer, right? Up to 1500 meter. This is wired communication technologies. Next comes the lot of wireless. That is a boon, wireless communication technologies. See, WiMAX, Wi-Fi. What is the difference? We can see from the data rate. Wired, there is no matching opportunity in wireless because it is 100 Gbps. But here nothing is there like that. Wi-Fi, it supports maximum of 1.7 Gbps. Up to only 100 meter like Ethernet. But Ethernet has a high data rate, right? When you're going for WiMAX, up to 50 kilometers supports. So WAN and all will be using the technology called WiMAX. So hereafter we should know that in our smart grid, based on the data rate, what technology we can, suppose if you are making a model of a smart grid or like that, we are giving a proposal. So at least after this technologies, after this, we should be in a position that what type of technology we can use for if my data rate is coming like this and my distance between the network, power grid and other distributors are so and so, what type of technology I have to use if I have wireless, okay? Zigbee, ZB. So these are the things, okay? So I don't know, you can refer these things. I have taken it from the survey paper, okay? It is 2022 or 21 paper. I have already mentioned this. Apart from that, you see 3G. 3G supports 42 megabits per second only. But when it coming to 4G, LTE, right, low terminal equipment, 979 Mbps. WAN, it supports WAN, right? Now coming to the narrowband IoT, you see, it supports 159 kilobits, very low data rate. That is used in smart meter reading. because we want all the meter will be continuously on, right? We can't able to switch off at any cost. Because if it gets switched off, then the power measuring will be get flopped. Some of the things we shouldn't get capture, right? So which the major requirement of these power meters, the sensors which is required is low power. Because the battery, if it is operated in the battery, then it has to last long, right? So we are saying that smart meter reading, NB-IoT is used, but it is of low cost. Also, if we are just giving it to a customer, they can't afford much. So these are the priorities we have to look when we are going for these smart systems to be deployed in certain applications. So I'm not going into much 5G, 20 Gbps. The maximum Wi-Fi that is, it is giving 20 Gbps when it is using, okay, long distance satellite 50 Mbps. So this is also man high cost, right? This is not defined because it is evolving 5G, 6G, cost is also high. And a lot of things also we have to take into account for making it this 5G into picture, okay? So smart grid communication technologies. And now I am going to take about what are the protocols which is deployed in this communication technologies. So what is the time now? I'll finish it, okay? Modbus is one of the protocol, all you know. Distributed network protocol. It's high speed over different types of electrical networks, including RFID, telephone lines, or even satellites. Ethernet IP, which is also another one protocol. This is a standard IEC 6185 interoperable protocol. Tackle functional integration challenges that are inherently complex. If you want a seamless integration, then you have to use this standard. Okay. So protocol supporting Internet of Things, you see the evolution of this. Yeah, I think whether it is clear or not, I have taken it from this paper. It's not paper, maybe from the industry or some chapters. You see that book maybe. Radio frequency has come 1901. 5G 2018 has come, but still it is evolving. Right? 2005 near field communication. 1997 wireless LAN has come. Wi-Fi, it's a boon. Bluetooth. These are the protocols supporting Internet of Things. Right? Why this Modbus is important? Secure and effective communication. Why this is important? Improves response times when multiple networks are utilized. So different protocols have different advantages. Why Ethernet is important? Compatibility for industrial equipment, because various industries are using Ethernet IPs, they are deploying there and making it compatible. What is IEC 615? It is an interoperable protocol. It also has some safeguard provisions against cyber attacks. Okay. And we know why need of cyber security is required. Then we know about the cloud computing, requirement of cloud computing, right? The ML techniques. Then we are saying that how this ICT has transformed the traditional power grid into an intelligent system, while important thing is minimizing carbon footprint. I have told that distributed energy resources like solar panels that generate excess electricity, which can be fed back into the electrical grid when not utilized by consumers within its vicinity. This is because of these ICTs. Firewalls installed between substation networks, right, to secure the transmission. Very much important, because unnecessarily the things shouldn't be get tapped or destroyed, right? Another important thing is storage mechanisms. You see, the data is get acquired. It has to be, sometimes it has to be stored, because if it is not utilized, it has to be stored for future purpose. That is also one type of smart, right? What is lithium-ion batteries are used, but lot of disadvantages. Nowadays, the advancement in storage mechanism has come. solid state batteries using sodium based electrolytes. Okay. Flow battery membranes. This is another one concept. Flow cells. Energy storage methods. Flywheels are used. Some generators are used to operate the fly, and it's a kinetic energy storage mechanism. Then the evolution or the introduction or the invention of supercapacitors. Store and release electrical charges. So these mechanisms are now flywheels, flow battery membranes are also now in the market in deployment of storage mechanism in the smart grids. A lot of what research is also required in terms of the storage mechanisms, right? So one case study I have given, a communication infrastructure with low power WAN. What are the requirements you see? Low power WAN network deployment, IoT device deployment, LPWAN gateway configuration. Then it is connected to cloud or edge infrastructure. Now we know the difference between cloud or edge. Then that has to be communicated through what? Protocol. The protocol has many layers. One of the things is security measures also, right? It has to be in that. So through these types of layers, once it will be communicating to smart grid or smart cities or whatever it is. Okay. So now you see this also I have taken it from that paper from the industry. Already we have studied, we know few large, this is the normal power grid, okay. Less compound power grid we can say, or a smart, it's also somewhat a smart system, but it's not a efficient smart system. One way, you know that normal power grid is one way power flow, one way communication. Passive energy consumption. Few large generation facilities, but it's not distributed, right? But now what we are going for, because of smart, we are making is complex adaptive energy, smart complex adaptive energy system. When you are making it, it becomes distribution, omnidirectional, real time, point to point trading. Now you see what is the inventions? Advancement in smart meters are required. Energy management systems are required. Digital substations are required. Microgrids, renewable and distributed energy sources are required. Energy storages are required. So in these areas, right, if you are doing research or anything, these are the areas that you can concentrate if you want to have improvement in smart systems. People who are in computer science or like that, they can take applications of smart grids with these digital infrastructures, protocols, and all those things, how to improve, make it smart, right? In electrical people, the smart meters, enable different energy sources, and all those things, the energy management systems, those things also we can make. So nowadays, everything we require smart. People are trying in your smart biosignal processing, right? In our day-to-day life, human being also want to be smart. If we want to be smart, how we can efficiently connect with sensors and we can collect data and intelligently will behave. Main thing is the time, how we'll save our time, how we will enrich us with good knowledge by picking all the data resources in and around us. Is there any possibility? That is making man smart, right? How things can be done efficiently without wasting time or energy or whatever it is. So these are things which is happening. Now you see, one of the standard in IEEE people are making, like, you know, in Wi-Fi, WiMAX, IEEE 802.1 or 802.3, like that, so many standards are used for communication protocols. Like that, for smart grids also, there is some evolvement of IEEE 2030 standard. So in each areas of these horizontals, there are some standards which is devised by the IEEE. Why it is required? Why standards are devised? For seamless integration, for seamless deployment. If standards are devised, then whoever the industry or people or the researchers, whoever is doing, they'll be following the standards so that it can be deployed in any of the system without much what is the difficulty, so that we can achieve the functionality easily. Next, challenges in implementing ICT for smart systems. Data security and privacy concerns is one of the important things. Network infrastructure limitations we have to overcome. Integration complexity across different systems. If it's a hybrid systems, or now we are saying that the smart grid has to be connected to the smart hospital. So many things are there. Standardization and interoperability issues. It's slowly solving if standards are defined or like that, right? But main challenge is nowadays data security and privacy concerns. Apart from assuming that all other things are in place, but whether we can effectively utilize is one of the important thing is the data breach. So cyber security research is also very much important. How we can strengthen the networks with good security, right? With that, I'm just ending my talk. Thank you.
Thank you, ma'am. Thank you very much, ma'am.
Oh, okay.
Bindu, ma'am.
Yes.
Thank you, ma'am. It's time
Madam?
for delivering the water. Ma'am, hello, ma'am.
Yes.
Thank you, ma'am. It's
Yes,
time
thank
for
you.
delivering water.
Okay.
Ma'am.
Shall I leave?
On behalf of, no, ma'am, please wait for some time.
Okay.
On behalf of Nurul Islam Center for Higher Education and the Department of Electrical and Electronics Engineering, I extend my heartfelt gratitude to Dr. Sheeba Rani J for delivering an enlightening session on role of ICT in smart systems. Her vast expertise in digital VLSI design, signal processing, and computer vision has provided us with invaluable insights into how ICT is shaping the future of smart systems. The depth of knowledge and practical applications she shared have greatly enriched our understanding and inspired meaningful discussions among participants. We sincerely appreciate her time and effort in sharing her expertise with us. Thank you, ma'am, for your invaluable contribution to this faculty development program. Thank you, ma'am, once again.
Thank you for the
Thank you. Thank you
patience.
very much.
Okay, good night. Okay.
Good night,
Good
ma'am.
night, ma'am.
Okay.
Thank you. Sudhya, ma'am. Ma'am. Ma'am.
Ma'am, we can leave, ma'am. Bindu, ma'am.
Sure. Okay, ma'am.
Okay.
Ma'am. Thank you, ma'am.
Okay.
Sure.
Thank you, ma'am. Thank you. Dear participants, thank you very much for your patience. So we have given that feedback form in the chat box. So please fill that chat feedback forms.